ladies and gentlemen. We are going to start the second Korea-Germany joint AAS Standard-Based Smart Manufacturing Forum.
Good morning.
So the first AAS forum was held in October 2020, and it has been 1 year and 5 months now, and now we are holding this second forum, so I'm very happy to see the hosting of this forum. In the first forum, we mostly talk about the AAS technology. So our first aim was to introduce AAS during the first forum. And in the second forum, we'd like to talk about the development of standard as well as the use of standard. And we'd like to share the current cases in Korea and Germany and online and offline forum to strengthen our cooperation between our two countries. So we are starting at 3:30 in Korean time, and we will host this forum for 4 hours. But we had to set up this schedule because of the time difference between Korea and Germany. I believe that it is 7:30 a.m. in Germany, and then you will have this forum until 11:30 a.m. So I'm sure that our German colleagues are up really early today. So this forum is organized by COSMO, the Korea Smart Manufacturing Office, and the promotion team. The COSMO is the host of this forum. And the sponsors include the CATS, AHK, and Platform Industry 4.0, LNI 4.0, SCI 4.0, IDTA, Anyang University, Nestfield, Seoul National University of Science and Technology, Gyeongnam Techno Park, and Smart Manufacturing Innovation Business Association of Korea, LS Electric, and BNR Korea. Currently, we have online participants up to 286 people. They are all the experts in the smart manufacturing field. And for the offline, we have about 30 participants here. We have prepared 70 seats today, so I'm sure that we will have more guests later. Next page, please. So as you were well informed, this is the agenda and schedule of today. So I will just briefly show you this presentation file, and I'd like to make some housekeeping notes. So each session will be given 30 minutes, including the Q&A time. So each session is limited to 30 minutes, including Q&A. But if you could not ask a question in each session, please use Zoom's chat window box to leave your question. And then we will have separate 30-minute Q&A session, and we will try to address your question during that time. And then the rest of the questions will be forwarded to the presenter, who will respond by email to you. And then you can also download the presentation materials, and that information will be sent to the registered email. And I'm sure that all those materials and the videos will be uploaded on the website so that you can download them whenever you want. So all the materials for this event are in English language, but Korean presentation materials will also be provided for Korean participants. So I'm sure that you can download later from the website. Now let us begin the forum. First of all, I'd like to invite Mr. Hyunjo Lee from the Ministry of SMEs and Startups, who is in charge of the Bureau of SMEs and Smart Manufacturing, Innovation and Planning, and Director General will give you the welcoming remarks.
Good morning. Congratulations on the AAS-based Smart Manufacturing Forum along with Germany, a manufacturing powerhouse, so that we can enhance the competitiveness of SMEs in two countries. Congratulations on the event once again. Because of COVID-19, we have some guests online. My thanks goes to Dr. Ernst Steckel from the BMWI and Dr. Martin Henkel, CEO of the German Chamber of Commerce. Anya Shimon, CTO of the LNI 4.0, Jessica Aiko from SCI 4.0, and Michael Billman from the IDTA. Thank you so much for joining us. President Park Hang-gu from Cosmo and Professor Hong Seung-ho, Mr. Song Won-seok, who is the research head of the NET field. Thank you very much. We are in the middle of the transition to the fourth industrial revolution or digital transformation. At this juncture, it is truly timely that the two leading manufacturing countries to collaborate on the AAS-based smart manufacturing and developing international standard together. And as you know, Germany is the first country that came up with the idea of Industry 4.0. Germany is a true innovator and has the top-notch competitiveness in manufacturing sectors. And they are also leading the standardization across the world. On the other hand, Korea is the leader in the 5G and semiconductors and has the most advanced telecommunication infrastructure. From the Beijing manufacturing like molding to advanced electronic companies like Samsung, Korea is a country of solid manufacturing portfolio. If the two countries can work together, I am sure the mutual strengths will make a success story in the smart manufacturing. For the last few years, the Korean government has been supporting the establishment and expansion of smart factories by encouraging cooperation between small and big companies and with active investment from the private sector. I am sure the future lies on not just making smart factories, but also using the generated data and analyze them with AI and build a digital twin. To achieve the goal, it is really meaningful to conduct pilot project over the Korean SMEs and to validate the feasibility that AAS standard can be actually working and used. For the last 2 years, we have been in collaboration with the manufacturers and made research on standard and reference data set development. And as a result, we made some progress in AAS standard. It was all possible thanks to the support of our German counterpart. And we have many pilot project, and I am sure the AAS has become more sophisticated. I believe the contribution from the Korea made the AAS more sophisticated, and I sincerely hope that there can be more practical and tangible cooperation between the two countries, and we can further develop the AAS standard and make it more widely available across the world. The two governments will provide the utmost support to that direction. The two countries share similar history and past experience. We have the history of national division, and we have talented human resources, and the two economies are export-driven. I believe the two countries can make a positive impact. And once again, congratulations on the second Korea-Germany AAS Smart Manufacturing Forum. Thank you very much.
Thank you very much, Mr. Lee, for the welcoming remarks. And next, we'd like to hear another welcome speech from Dr. Ernest Skolman-Puckel from the BMWK of Germany.
Dear Mr. Lee, dear President Park, good afternoon, ladies and gentlemen, dear Mr. Henkelmann. I'm very happy to be part of this meeting today, and I warmly thank our Korean partners for inviting me as a representative of the Federal Ministers for Economic Affairs and Climate Action. And thank you very much, especially for organizing the event of today. As you said before, Korea is an important collaboration partner for German Asia. We are sharing same values. We are both very strong industrial countries. And so we are more than happy that Korea shares the views with us regarding Industry 4.0. We share the view that for future competitiveness, Industry 4.0 and concepts based on data, based on digital transformation are very important to secure growth in both of our countries. So we are very happy that our cooperation is constantly growing since years and that we have reached today another step of really intense cooperation. By now we have established 3 joint working groups, one on international standard development, one on Gaia-X, and thirdly, one on cybersecurity. All of those working groups really carry fruitful cooperation forward. Let me highlight some achievements from my perspective. First, we are very happy that Korea has founded the first Gaia-X hub outside of Europe. And now the hubs of our 2 countries, we have in Germany the first hub, we had collaborating and transferring knowledge. I think it's very important to put a focus on data exchange, on data sovereignty, and Gaia-X is one means to reach this goal. There's still a lot to do, but we are very happy that you share these views that we should move forward with regard to those data infrastructure issues. Secondly, we can be very proud that we managed, Korean government and our ministry, to finance a joint research project. This is not always easy to organize, but we managed in last December to finance this project, and so we will gain joint knowledge on post-quantum cryptography and edge management in manufacturing. I'm very curious about the outcomes of the project and wish this project a lot of success. I think the results will, from the results, we can benefit in our working groups. And the working group on international standards development has been exchanging on asset administration shell intensively. Today, it's already the 2nd AAS forum, and projects on AAS testbeds are running already in both countries. The achievements will also be displayed at this Hanover Fair in May and beginning of June. In Germany, stakeholders in the digital systems are guided by the 2030 vision of the platform Industry 4.0. It defines 3 important pillars: autonomy, sustainability, and interoperability. I always like to underline that when we talk about autonomy, it does not mean to have borders and to separate everything, just the opposite. We want the free flow, but in a sovereign way, that companies and the owners and users of data have the control what they really want to do, to develop sharing mechanisms and joint mechanisms to develop business models jointly. Today, we meet in the context of enabling interoperability. This means, for example, to enhance the communication between machines, products, plants over the life cycles. However, interoperability requires a lot, and it's more than simply connectivity. In our understanding, it requires clear semantics. We need data integrity. We need cybersecurity and we have to establish rules of governance, and the sovereign usage of data based on open standards has to be organized and understood and standardized. With the asset administration shell, we can realize a lot of those requirements. And we can develop those data spaces we will need for future business models and for future competitiveness. So I appreciate that the development of the AAS is driven forward. Activities via testing, international standard development, and market-oriented solution will support to meet the needs of companies of all sizes. And we all know we have to put a focus on small and medium-sized companies who need really to have simple concepts which are simply to apply. Coming to an end, I would like to thank all parties engaged in deepening our relations between Germany and Korea in Industry 4.0. This is a real contribution to increase resilience of our supply chains in the future, and it's a great opportunity to use digitalization to increase sustainability in our industries. Today, I especially thank Professor Hong for guiding us through the event, and Mrs. Simon from Labs Network Industry 4.0 as the German chair of the Work International Standard Development. Thank you very much. I wish that today's workshop a big success.
Thank you for joining us starting from early in the morning. Orange, thank you very much. And from KGCCI, I believe it is the Korea-Germany Chamber of Commerce, as far as I understand. The CEO, Dr. Martin Henkemann, will deliver his welcome speech.
Very much, Professor Hong, President Hang-Gu Park, the Director General Yun-Cho Lee, Mr. Ernst Stöckel-Pukal, dear co-speakers, and ladies and gentlemen. I'm very delighted to attend the second Korean-Germany joint AAS Standard-Based Smart Manufacturing Forum today. As long-standing partners, Korea and Germany share many similarities. Our countries' economies are export-driven and have a very strong manufacturing sector. According to Bloomberg's Innovation Index, Korea and Germany are two of the most innovative countries in the world. As manufacturing powerhouses, it is great to see that both of our countries are closely cooperating to accelerate innovation regarding digitalization, standards, and Industry 4.0. Korea and Germany have a successful track record in developing and implementing smart factory solutions. In digitalization and smart manufacturing, interoperability is crucial. In this context, I would like to quote one of our members who recently said, digitalization needs interoperability and interoperability needs standardization. One of the biggest obstacles in the digital transformation is the lack of standards. Standards are a way to make things easier. Standards are a prerequisite for interoperability. We should consider this challenge as an opportunity for Korean and German stakeholders who are leading the field in smart manufacturing. Together, through a standard-based approach, we can shape the future of smart factories. KGCCI is supporting the collaboration between Korea and Germany in this field. For example, we have a digitalization working group here in Korea that we connected with the colleagues from Platform Industry 4.0 and the Labs Network Industry 4.0 to share updates and ongoing joint initiatives. Also, the German Chamber's umbrella organization, DAHK, the Korean Chamber of Commerce and Industry, and we from the Korean-German Chamber co-organized in January the first joint business council, and it focused on digital transformation. Representatives from Korean and German companies shared insights on company-specific and joint initiatives and agreed that cooperation between both countries should be further expanded. Unfortunately, we have recently seen increased uncertainty due to the pandemic and heightened geopolitical tensions. We are also noting decoupling trends globally. All these are tearing major economies further apart and disrupt commercial flows. But the joint development, testing, and utilization of standard technology is key, particularly for export-driven economies like ours. Germany generates 43% of its GDP from exports of goods and services. Korea's exports amount to 36% of its GDP. These are much higher shares than usually in the OECD, where it lies the average at 26%. Since exports play such a vital role to our two countries' economies, it is crucial that the innovative smart factory solutions made in Korea and Germany are globally compatible. This can only be achieved through a standard-based approach, for which the cooperation between our two countries is crucial. This conference presents an excellent opportunity to do exactly this by sharing knowledge and experience and initiate new pilot projects. This cooperative approach will strengthen the leading role of our two countries in relation to Industry 4.0. Additionally, today's conference is very timely, as it will contribute to weaving the tissue of our partnership even tighter. We look forward to continuing our support of enhancing business relations between Korea and Germany, also in this field of smart manufacturing and digitalization. And there are many opportunities to do so, as we can see with today's conference, as well as with various other upcoming events, such as the Hannover Messe, which was already mentioned. I'm looking forward to a fruitful cooperation and very interesting conference today. Thank you very much. Kamsahamnida.
Thank you very much for the speeches. And now we will fully begin the second Korea-Germany Joint AAS Standard-Based Smart Manufacturing Forum. First of all, Mr. Hang-gu Park, who is the president of COSMO, will talk about the promotional strategy and action plan for innovation of smart manufacturing in Korea. I'm very happy to see you all. I believe that it is about 8 a.m. in the morning in Germany, and I'm sure that you are very up very early today to participate in this forum. So thank you very much for being with us. From June 30 to, May 30 to June 4th, the Hamas Mass will be hosted in Germany, as far as I know. And our staff members, as well as the experts of this industry, would look for the opportunities to participate in that event. The topic that I want to talk about is the implementation of smart manufacturing innovation. And then we will close this project really soon, and then we will move on to the next national project as we take us one step forward. In 2014, we started this project, and then we went through this project in 2018 and 19 and etc. And this is the vision of that project, as you can see here. Our goal was to improve the life of Korean people with smart manufacturing innovation. So about 30,000 smart factories and SMEs have participated in this project in some ways to improve their competitiveness. And then actually this is an opportunity to encourage such 30,000 SMEs to make them smart factories. And then until last year, we have reached 25,039 in terms of the number of smart factories from 2014 to 2021. And then the minister who was in charge of this said last year that we shouldn't focus only on the numbers, but we must focus on the quality itself. So actually, rather than focusing on the number, we started to find measures to actually give right support and good help to the SMEs and companies. And in this way, we are supporting these companies to become smarter. And we are also supporting the SMEs to become really smart companies and smart factories. So as I said, that the result of a performance survey of 7,903 manufacturing companies built smart factories between 2014 and 2018. So 7,903 manufacturing companies built their smart factories, and we compared before and after. And you can see that productivity was increased by 28.5%, quality up by 42.5%, and then the employment rate was up by average 2.6 employees. So you can see economic values from the slide. And also at the same time, as I said, our goal was to improve the life of people. And if the productivity is up by 28.5%, we believe that we should have better performance. As you can see, so you can see that we have many different vendors to complete one product. And then most of the SMEs who are involved in this project are in tier 2 or tier 3. So even though their product productivity level goes up. For example, if one company used to manufacture 1,000, but if their productivity is up, so if they can manufacture 1,300, that means they need to have the right buyers to actually buy these products. So that is why we kind of newly categorize these participating companies. So we built the level 3 smart factories by company for 3 years. So we will vitalize this project continuously, and from next year, we will fully launch this new measure. So we are going to categorize these companies all together in a group, and so that we can support building and utilizing a shared platform after building a level 4 and maybe up to level 5. So we will focus and we will concentrate our efforts to support these groups. So in that case, if one company's productivity goes up, they will have more buyers so that they can actually make more sales. So that is the way in which we are making efforts. And in order to promote this kind of project, what do we need? So until now, when we were focusing on the smart factories, we usually focus on the solution and computing technologies, which were mostly built and operated inside the company, for example. So they had to hire IT personnel who could be in charge of that, and they needed a lot of electricity to use, and they had to renew and update the hardware every 5 years, for example. And for the sake of security, they had to invest in the security solution very much. Otherwise, they could not maintain this. So the cost was an issue, and in order to solve this, from last year, we changed to cloud-based computing solution. So it is called the Korea AI Manufacturing Platform. It is the camp that we built last year. And if the manufacturers want, then we select the cloud service company, and then we added like ERP or PLM or SCM on top of the cloud and operate it, so that these participating companies can pay only up to their use, like a subscription economy. So that's the support that we are providing to these SMEs. That means from the perspective of SMEs, they could use the gateway server and they could collect and store data from it. And then the data will be uploaded on the cloud computing. And in the cloud computing, ERP or PLM or SCM or big data based AI or VR or AR. And these kind of solutions will be applied to bring economic values in these companies. So in this cloud computing environment, and in order to operate ERP, PLM, or SCM, the most important thing is not to have as much customization as possible. So we should have less customization. So for example, if we apply a solution to another institution, then that means the cost will go up and economic value or the way of work are not changed from the past form. So we need global standard and global platform and global solution. And if we don't make such a change, then during the fourth industrial revolution era, our manufacturing companies will find it very hard to make the lead. For example, if we have ERP and if MDS will be applied later, then we need to pay the ERP solution companies to actually connect it, and then it will request a lot of time and cost and etc. That means we will be able to exchange less data. That means we will not be fully use this. So that can be an issue. And then if we go to the global market, and if we just sell physical products, then it could be possible, but it is not like that anymore. So we will make data as products, just like crude oil. So in the future era, where the data will be considered as capital, this kind of solution is necessary. So we started to promote from last year, and then this year, we need to make more efforts to select the cloud service providers. And then on the path supported by these companies, we need to build a socket, big data, and ERP, PLM, and MDS, and etc., so that they can be all played on that platform. And then when we have the AI solution, then we will be able to play this very easily here. So we need AAS-based interface and AAS-based standard so that interoperability will be secured in this industry. So that is the big goal of the Korean government. So we will make this as one big software package so that SKT or KT or Naver or some global cloud service companies like Amazon or Google, we will be able to provide this one package so that they can use it very smoothly. So as you can see here, it's less customized and it is more standardized. And in order to do that, we have 6 categories, as you may well know. And then we increased to 14 last year. And then we have 25 industry types, as you can see here, like ERP, SEM, PLM, MES, and AI solution, big data solution, and etc. But we need to have one single package. And if we operate in this way, then our manufacturing companies will be able to have global competitiveness in the future. And then after verifying such a standard in Korea, we can also sell this kind of standard to global market. That means the softwares that we have can comply with the global standard. So if we don't develop standard-based solutions, and rather if we have the customized solution, then we will not be able to sell in the global market. So what is necessary? So ERP system, PLM system, SCM, and recently many startups have developed AI solutions, and all of these will need to comply with the global standard in terms of the architecture and function. So the government will make utmost effort to support this area and industry and players. So if we don't change the way we work, then we will just we will live without productivity. We will just take everything for granted and do not make any efforts. Let's say if we give promotion to a person after 2 or 4 years, and if we just change the organization and etc. And in order to give some motivation, then we are trying to find many different ways. So we started with the ERP in this project, and then automation and smart innovation and etc. And we have gone through all these exchanges. And during that process, Korea's SMEs grow themselves and startups become SMEs and etc. And we want them to become the global hidden champions of the future. So all these different countries have different background. So for example, for a single company, we can find, let's say if this is a pressing company, then we can make the most appropriate ERP solution or other kinds of solutions and etc. But if they all join together with a different background and make an alliance, then they can select the cloud service provider, and then based on that, they can also collaborate together. Then they don't need to pay the initial cost. Rather, they just pay whatever they use per month, for example. Then we can expect economic value, and the way employees, like workers, work will also change in the future. And if they change, then their achievement or the level of satisfaction and productivity and the safety and the completeness of the products will all go up. And not only the products, but also the data will be sold as products in the future. In order to do so, many companies have to make changes, but they are not willing to change yet. But like 70% of the manufacturing companies by 2025 will need to change, make changes, and they will migrate from the on-premise. So that means like even in like developed countries, many leading companies have already made changes. And what I mean by this is that many companies are already making changes to actually use this cloud-based platform. So if they use as an on-premise, for example, the cost would go up from, for example, 600 billion Korean won to 1 trillion Korean won. So you might be worried about the security or the leakage of data, like openness of data or the economic value. So that is why many manufacturing companies are reluctant to change to the cloud-based service, even though they want it. But what is more important is that we know that there is a necessity, but maybe the insufficient technology is kind of hindering them from making a change. It's because in order to make one package, we need to trust each other and communicate with each other. And when we have the profits, we need to have this platform to have candid communication, but we don't have it yet. So maybe that is why these companies are kind of reluctant to make changes. But about 50 companies are now making a lot of efforts to change to SaaS. So, and they're making a lot of changes actually. So as I said, our goal was to reach like 30,000 ERP from year 2001 to 2003. And the ERP system was about 300 million Korean won. But can you actually adopt it easily? It was not easy. So the companies with packages could not join the government-led project. But some others joined this project in order to deal with this kind of accounting by buying this ERP system. And then they put this on to make sound balance sheet and etc. So at the beginning, when we did this, we had to draw this ERP framework, but people just adopted whatever they could to make a good balance sheet inside their company. So it was not done well. So that is why the interfaces of the modules are not interoperable, but the speed is not good. So these problems are occurring. Internal Revenue Service is an organization of the US. And then for the soundness, the financial soundness, in the ERP, they had to have this algorithm and this system and etc. So that is the global standard. But SMEs just developed in a customized way. So they were not well developed. So that is why they could not be sold in the global market because of these customized structure. So if you want to use the cloud service, then you need to have a global standard-based ERP, like PLM, SCM, and MDS system. And then you will have virtual computer room, and inside it, then you will need the ERP solution system for the fiscal and financial data of the company, and then MNES system will be established. And then for the R&D, PLM solution, and SCM solution for the customer management and etc. will all be established. And then in this way, you will be able to have even stronger and more secure system compared to the past ones. Like the digital cluster, as I mentioned, you can also exchange data between the suppliers as well. Then in this way, you will be able to create a whole new value and maybe some other values as well. So this is one of possibility as well. So as of now, you are the ones who are in charge of the maintenance and repair, but the suppliers will be able to monitor the data, and then they will be able to monitor the quality of the data, and then make additional services to make improvement, or maybe change the compartments and etc. So auto maintenance will be done in the future. And another important aspect is that in addition to selling the hardware product, you will be able to administration and sharing based data sharing system. In this way, you can store the credible data, then you can also make product out of credible data, and you can also sell it. So you can apply the data to your own product. So you can realize these 4 business models. So when we conducted a survey, we came to know that the hardware on-premise was about 17%, but if we change it to the cloud service, then it will decrease to 14%, and software will decrease from 20 to 17%. So compared to your computer system, if you use SaaS, the total cost ownership will be minus 8.1. So we can achieve 8.1% of economy effect in terms of total cost of ownership. So we are especially collaborating with Germany. In 2020, we signed the MOU with LNI 4.0 for cooperation to fast-track the digital transformation of the industry by building the test bed. So we are now testing the asset administration shell, the AAS and OPC UA testing and implementation collaboration. And then there is an organization in charge of the standardization, both in Korea and in Germany. And then Kosovo and LNI 4.0 are now collaborating on test beds. Google, Microsoft, Amazon are kind of dominating this technology in the world. And then in order to improve interoperability among different players, we need to make some rules, right? So that is the Gaia X, and Germany is now leading the way. So last year in November, we had this meeting together with the Gaia X European Association for Data and Cloud AISBL, and Korea became a regional hub of this region. So we are now collaborating together. So we are now collaborating with the LNI 4.0, as I said. And then we are now making this AAS-based data acquisition system. So we are getting the HK2 data and time 3, and then we are now storing in the cloud, and then we are now developing this software, and we are providing as open source to the participating companies at free of charge from last year, and we want to further vitalize this project. And then, yes, last year that we move on to tier 2, like phase 2. So in this way, we will be able to manage all those things in the life cycle. So we are now testing this on our test bed. That means AAS-based business paradigm will be changed, as you can see here. For example, if we manufacture one car, then the AAS-based design will be completed. Then other parts like the axis or the surface design and etc., or other detailed concepts will be designed and simulated based on this AAS. And then those smaller partner companies will be able to do their job, like detail simulation and bolts and nuts assembly and etc. So all of this will be manufactured and simulated based on the AAS. So the perfect simulation will be done on the AAS, and if we perfectly complete it, then we will be able to move on to the manufacturing. And if we sell this hardware product, then the AAS digital twin will also be able to sold in the future. So that's going to be the essential business model in the future. So security interoperability among CSPs is really important. So as I said, the Gaia X has been developed. Now it's under development. So in this way, we'll be able to migrate, and then the KT or LHN or LGCNS or LSKT cloud service providers will be able to interoperate together in this new system. And lastly, as we are collaborating with Germany, so there is a platform called Germany Industry 4.0, as you can see here. So with Germany at the center, France, China, Japan, India, and Korea are now joining hands together as we joined last year. So we are now making this AAS center-based smart manufacturing transformation. I'm sure that we will move on to the win-win structure for all of us in the future. So thank you very much for your attention for the past 30 minutes. And I sincerely hope that Germany and Korea will know that the manufacturing, which account for 28 and 23% of the total GDP in Germany and in Korea, will be better valued. And we hope that we will be able to further strengthen cooperation between our two countries for this industry. I will see you all, my German colleague in Hanover, on May 30. Thank you.
We are a bit overdue, but anyway, we are going to finish this meeting 7:30 sharp. I'm going to manage the time that way. President Park, thank you very much for the wonderful presentation. If you have any question, you can ask a question right now. And among the online participants, you can post your question on the chatting menu, and we are going to collect that and pick that up during the Q&A session. Currently, on the floor, physically, I do not have a specific question, and we can come back to the discussion during the Q&A session. Now, I would like to invite the second speaker, and we have Mr. Song Won-seok from Nestfield, and he's going to tell us about his pilot project in Korea, which is, of course, based on AAS. Morning, good evening. I am Song Won-seok, who is the R&D head of the Nestfield. Today, I'm going to tell you about AAS-based pilot project, which is conducted in South Korea. This project has been conducted for a long time, and we have been collaborating with various experts and various entities. Thank you very much for your collaboration, and thank you very much for your support and help. Thank you. I personally is a software developer, and in this project, I've been in charge of the solution design and solution development. So today, maybe, I'm going to tell you more about some technical stuff, like what kind of a solution has been implemented. But it's not going to be a technical deep dive. I'm just telling you why these kind of activities are really necessary and what is the implication of these kind of activities. Lots of things are going on right now in Korea. Today, I'm going to introduce the AAS related technologies and some of the key implications that can have direct impact on the AAS. As you can see on the table of contents, I have the 4 bullet points. The first one is the Aas reference model, how we develop the reference model. The second one is really important part of the AAS development roadmap. And you may heard about the API and repository. I'm going to tell you more about the API and repository development. When we were working on the project, we developed some of the solutions. I'm going to tell you how these have been applied to the system and how AAS has been incorporated into those technologies. Based on these 3 components, I will show you. Actually, we have 2 machines are co-working together, and we have the collaborative testbed right now. I'm going to briefly introduce you how we have built that testbed and how the testbed has been working. Let me begin. First, AAS reference model. The objective of developing a reference model is to make AAS widely available in South Korea and easily available in South Korea. In the first round of project, we used the AAS technology to collect the data from the shop floor. And we applied that and we validated that. However, when we want to deploy that to the Korean shop floors, many people are kind of worried about the development of AAS. So they are a bit hesitant about applying AAS to their shop floors and the factories. So what we wanted to focus on is to make a reference model that can be widely used for the widely available machines in South Korea and widely available processes in South Korea. So in the second round of the project, what we focused on was developing various reference models. And the target systems are the motion device system, the 6-axis articulated robot, AGV, CNC machine, injection machine, and those were the target devices we worked on. And we created AAS model for these devices. As for the welding and the EV battery pack, we are currently working on the modeling right now. From each of the domain, there are better experts than I am, and they bring up the flagship devices and they gave us a navigation guideline so that we can help a commonly and widely available reference model for the widely accepted devices. For us, the robot reference model was a bit special because this is the first model we ever created. We went through various steps and the model has been quite advanced because we were going through a long enhancement process. We have the robot reference model for the 6-axis. You can see there are 473 properties. You can simply refer to the table. Not just the status information you can check out on the shop floor, but recognition information and some technical informations are also within that model. We refer to lots of documents. We did not create that from the scratch. And OPC UA companion specification, E-class, and the PI 4.0, they have produced some documentations, especially for the sub-model specifications. Also, we refer to some of the commercial data sheets available in the market. And based on that, we recreated a reference model that can be commonly used in South Korea. We made a model and we invited the experts from each of the domain and each of the standards. We validated it and enhanced the model once again, and we opened the model to Germany so that it can be reviewed by our German counterparts. To make the model, we were going through some processes, and we have some of the other materials which can back up the process, and we have opened those materials as well, so you can have access to those information, how we develop that. And currently, we are working on various models, not just a robot, but we are currently developing many reference models. A AAS reference model needs to be verified if there can be really feasible option in South Korean factory. And there is a collaborative robot manufactured by the company Neuromecha. The model name is Indy 7. AAS reference model was applied to this robot, and we have worked on the verification. This robot is supporting the OPC UA And even without OPC UA, we used other protocols. So we worked 2 times, one with the OPC UA and one without OPC UA. We used AAS and we were able to collect the data. The collected data on the cloud was analyzed, and we used the 3D dashboard that you can see on the screen on a real-time basis. This is really meaningful because the reference model can be used for the commercial products, and we were able to collect the data. Now let me tell you about REST API and AAS repository. In the PI 4.0 specification, yes, they have many documentation. They talk about information exchange via API. You can see the title of that documentation. The key point is written on the right side. You can see the diagram at the bottom of the right side. This is showing how AAS will be developed. This is a kind of the roadmap. The first step is the file exchange. This is what we did in last year. AAS is more like a representation of the property of assets. And the representation can be done via file. And if we make the representation as a file, the file can be exchanged. And the third step is among the AAS, they can mutually share the data and they can have autonomous interaction. That is the ultimate goal we have. The second step is API. To make the autonomous communication, AAS should be connected to other external devices or external AAS. So we need to have the outbound communication. To enable that outbound communication, we can utilize API, and repository can be the source of the data to send some of the data. We have utilized the REST API, and also we build our repository. Now the service is online. We are currently using that. Also, we have the web-based package browser, and the package browser can be the key UI that you can use this kind of service. This is the internal process. This looks kind of busy, but there is an asset, and you identify the asset. You got the asset ID. Based on that, you bring the AAS information, and within the AAS, there is some models, and within the submodel, you can see the more granular contents. And all this can be done on the web. And this is the API standard. And this kind of API can be supported with the repository. And you can see how the AAS information can be stored in our repository. And we have the web application called the package browser. And you can see how they are expressed or presented on our UI. Of course, REST API technology is in the middle. And I would say this is one of the most important technologies to make AAS more autonomous. I believe API can be the key foundation. And we can have the web version of the deployment of the AAS via API. Then the security can be the key issue. There can be some cases anybody can take any information that can be problematic. To relieve the concern, in Germany, they are using OpenID Connect. It's a kind of the access control. And as you can see here on the picture, when you want to have the AAS access via web server, ID and password, your credential needs to be verified, and there will be the authorization token. And based on the authorization token, you can get the information from the AAS, and your role-based access can be managed. Just like you are using the Google ID. When you have the Google ID, it's more like a single sign-on. This is more like a single sign-on. And we have the access level authentication information. For each of the property, the authorization management needs to be developed in the future. So authentication is available and authorization needs to be further developed, and the privilege management needs to be further developed. So far, I'm telling you about the Aas reference model, and they are really important in the development of Aas in Korea. To make it more interactive and autonomous, Aas repository and API are the key components. And during the project, we focused on the implementation of the repository and API. And many other technologies were updated. There are some technologies not directly related to Aas. For example, API specification. But today, what I'm going to tell you is this one. This one is directly related to Aas. I'm covering only the updates directly relevant to Aas. This is the 3D image view, and you can have the view on the 3D image. This is a new update. On the Package Explorer, this can be supported. And actually, this has been covered by the demonstration from the German side. Aas is not bringing the shop floor information, but design, engineering, and technical data can be brought via Aas. So the design-related information can be reviewed and validated. So that kind of functionality is really necessary. So on the package browser, this kind of 3D image file can be viewed. This is the new feature we added. The most widely used file format is the STL. So currently, we are supporting the STL file format. As you can see on the picture, this is the package browser we have, and on the right side, you can see the 3D image. For those of you who do not know about the package browser we developed, there was a package explorer to make an input onto Aas that has been developed by LNI 4.0, and that software has been further enhanced. That can be run on your PC, and you can use the Aas. However, in our solution, we have similar feature, even though we are not putting input with our browser, but we can core the information and we can see the information. That is the web-based package browser. The UI is pretty much the same as the Explorer we had before to make it easier to use. So I would say this is the web-based package explorer. Another one is mechanical breakdown. Actually, that was covered by the German side. And within the Aas, the feature is available. When there is a single asset, you know there are some sub-assets. In that case, mechanical breakdown can be used. And you can move around among the various assets. As you can see, On the robot arm, there are some parts. And when we make an asset modeling for that, when you are looking into the robot, but when you click on that specific asset, the joint asset can be popped up and you can see more detailed information. This kind of dynamic UI will be available to you. Of course, we are using API and we can bring the asset information from the repository. When you use this kind of mechanical breakdown, you can see and you can have a really granular modeling, especially for the part which has various subcomponents. The third one is you can see the data on a real-time basis. I mean the shop floor data. In the package browser, you created another UI to check out the shop floor information. That was how it was working. And now on the browser, you can see the data directly. You don't have to toggle around and you can see this kind of data and you can see the flow of the data, whether there is any abnormality or not. When you are using this kind of solution on the shop floor, this can be a really convenient one to the operators. The next one is data execution or the decision execution. Decision execution is on the cloud, you can utilize the data. Once the decision is made based on the cloud data, you should be able to apply that to the shop floor. In the first phase project, we were able to collect the AAS data. That's how our solution was built. And as you heard, and in various cloud environment, we can utilize various analyzing solutions, and we can utilize those data. And after that, we can make a decision. We can make configuration change and parameter change, and those changes should be updated to the field. To make that happen, we have the execution feature. Now, if we collect the data from the shop floor and once it is analyzed, it can be fed back to the field and to the field devices. I told you about the 3 key features and I told you about various updates. Using all of them, we have now 2 equipment and we have the testbed where 2 equipments are collaborating together. And you can see 2 machines and they have their own AAS. 2 of them can be connected and we created a single testbed. Now let's imagine how the life has become more convenient. We have injection machine and we have the robot. I told you about the reference model because we created the reference model for the injection machine and the 6-axis robot. We have a company called Ujin Prime and they have the TE110. This is the injection machine. And I told you about the Indy 7. This is the 6-axis AAS robot. When we are combining these 2 assets by utilizing AAS, and we wanted to see what will happen. You can see the photo taken from the shop floor. The testbed is located in Ujin Prime, located in Poeun area in South Korea. And you can see their R&D center. And within their R&D center, we have located our testbed. And we have the injection model and the robot arm. They are working together. This is the operation scenario. The injection machine is making a product. A small object or product will be made. Once the product is made, the robot will pick up the product and it's going to be put onto the robot stack. And robot will pick up the product and move it to the scale. It's going to be weighed to determine whether it is pass or fail. Based on the information, the robot picks up the product once again and put it into the either pass or fail boxes. This is the configuration. Through the edge onto the cloud, the information will be stored. And we have the application that can exchange the information between these two machines. Data exchange is really necessary to share the information. As I told you, we made a data exchange mechanism between the two. If AAS can share the data together, it's going to be really great. However, that's going to be the future, something that we need to do. This is the scenario. Capability check means how capable this machine is. This has not been implemented yet, but this is going to be really important. That's why I want to tell you about capability check. Before making the integration between the two, you need to check out whether the other side of the machine can actually do the behavior that it is expected to do or you expect it to do. Then you identify the asset, whether the asset is the right asset you were looking for. After that, you validate whether the mold is installed in the injection machine and whether the right mold is installed on the injection machine. And after that, there must be some matrix for the pass and fail. And that kind of configuration needs to be delivered to the robot AAS. Whenever the product is changed, the new matrix will be given to the robot so that the robot can know whether the new product is fail or pass. And we can use the robot data and engineering data. And after that, we start our operation. Let me play a video clip. You can see the product, right injected, and status should be shared so that there will not be any collision between the two machines. Robot is picking up the product and put that onto the scale. And the robot already knows what is the matrix for the fail and pass. It makes the decision and put it into the right box, either fail or pass. Those two machines are working independently. The data exchange is done via the external application. Another video clip. In the case of an emergency, the emergency information is shared between the two. Now you can see when the injection machine is stopped, the robot is stopped. This kind of integration was made. And we were able to see the collected data on the cloud, and 3D visualization was also possible. The biggest benefit is you only need AAS. AAS has all the data, and AAS can help you share and exchange the data. Of course, it is not autonomous yet. Anyway, the AAS can share the data, then we can think about various applications for the future. As I told you, in the future, when AAS can autonomously share the information and interact among themselves, that's going to be really great. That is something that we are pursuing after. And we are currently collaborating with the IDTA. And we are pretty much focused on the AAS autonomous interaction among them. And now we have a AAS network. This is an international project. There are lots of test beds. And in Korea, we have some of the test beds. Those test beds can be connected together and we can create a better scenario. This is a longer term project. We are currently collaborating more with our German counterpart. Thank you very much for listening.
We will address maybe two questions if there are any questions from the floor or in the chatting room box.
Later, we can cover those questions during the Q&A.
Next, we will move on to Mr. Meg Billman, who is the CEO of IDTA, which stands for Industrial Digital Twin Association. And I believe that not only German companies, but also all the companies around the world can join this association. So Mr. Meg Billman will introduce the IDTA.
Good afternoon to Korea. It's a big honor to be here today with you. Thank you for the close cooperation in the past few months. I heard the first or the last forum, joint Korean-German forum, was in October 2020. Our organization, the Industrial Digital Twin Association, did not really exist at that time. We were founded in September, so we existed on paper, but our operation started in April last year. I'm the general manager of the Industrial Digital Twin Association. My name is Mike Billman, and I would like to introduce our association and our activity, especially with a focus on our joint activity together with our great colleagues from Korea. I was really impressed what Dr. Song just presented, impressed about the deep knowledge about the AES. Because we are convinced that we need to build joint forces to have a standardized digital twin across the globe. And we think the asset administration shell is the perfect foundation for this digital twin. So we are really happy to see those projects in Korea. Looking at our membership, we started with 23 members. Last year, we are today 60 members, and we were really happy that our first international members were from Korea. It was Aas Electric and at Nestfield. Looking at the overall structure of our members, it's really good to see that we have a lot of suppliers, but also machine builders, software companies, and also end users. Our biggest end user, for example, is Volkswagen. So this is great to see, because I'm going to show this on my further slides. We need to have the whole value chain within the development of the digital twin for the industry. From our background, we started in platform industry 4.0 like 10 years ago. I have this on the next slide. And historically, the automation companies were really strong in developing asset administration shell and RAMI the last, let's say, 10 years. So what you see is that especially the large automation companies are very present on this slide deck of our members. But what we are starting to collect a lot of software companies, which is really important, because basically we are talking about software in addition to all the hardware and automation equipment. Looking at the evolution of Industry 4.0, we see that we started already in 2011 with the foundation of the platform Industry 4.0. The concept of asset administration shell was introduced in 2015, and in 2020 the industrial implementation of the asset administration shell started. So we saw the first demonstrator, we saw the first really live applications running in companies. At that time, Platform Industry 4.0 discussed that we need an organization, something like a user organization for the asset administration shell. Since platform is run by the government, we were discussing now we need this kind of user organization to have, especially the topic of the asset administration shell within one, concentrated with one company or one association. And this was the idea to create IDTA as a user organization for the asset administration shell. So you know it from, for example, OPC UA. You have the OPC Foundation, which is the user organization for OPC UA. And the same is IDTA for the asset administration shell nowadays. What's the target of organization? Our target is to build a global community. That's why it's really important for us, and we are really happy to have the companies from Korea on board. We are working, of course, on different companies to have them in our membership. But what we want to do is to build the global community around an international standard. So the asset administration shell, you already know that, is standardized in IEC. So we are in the process of having an international standard, and we are in the process of building the global community around it. Second target is to have open source software, to have this software and every resource is available for all companies across the world, regardless of their size. So we are also really happy to have the first Korean projects integrated in our open source platform, which is really great. Again, Korea is the first international member who's integrating his projects on our open source platform. We also want to give open access to the information models. So we are building, just last week, we started to have an open catalog of our information models on our website. I'm sure there are going to be also Korean information models. We already discussed this around these use cases, which Dr. Song has shown us. And we want to have market access through matching use cases. This is also something Dr. Song already represented. We are working together with Labs Network Industry 4.0 to have those matching use cases to bring AAS into the shop floor. Just yesterday, we discussed to have further demos, and the inspiration was the asset-based pilot plant from Korea for that. The colleagues of Volkswagen were starting discussions with us, and they said, oh, we want to have also a AAS-based pilot plant at Volkswagen. So this is great news to have something like this, what you already have in Korea, in the future also in Germany. Last thing, we want to create a training, and we are already discussing having exchange on the training with the Korean colleagues. We have built out a training program, and there's also a Korean training program. We just exchanged our contents, and I'm sure we're going to have a close exchange on that level in the future as well. The AS as the enabler for the digital twin. I'm going to have a short excursion into the technology. What's so special about the AAS? Looking into the market today, we have a lot of digital twins. You have application-specific digital twin. You have high performative digital twins on certain aspects of the life cycle. What's really new with asset administration shell to have an efficient standardized digital twin over the complete life cycle of products and productions. So this is really the revolutionary step we are taking with the asset administration share nowadays. What's the content for this kind of digital twin? The idea is to have it over the complete life cycle, meaning it begins with engineering. The first 3D models, the first drawings of products go directly into the asset administration shell as the digital twin. You can run simulations. You can have all the properties about your product integrated into the digital twin, which exists before the product even exists. Second thing where we see huge impact is having all the documentations, all the certifications, all the information somebody needs to run a product or a production available digitally, which is nowadays really important and an impact on sustainability, because you don't need all the documentation on paper, which is, for example, in Germany nowadays, or in Europe nowadays, a regulation topic. And of course, the digital twin has a huge role in operations. Means we are able to put live data from the production floor, for example, via OPC UA, right into the Aas, and we are sure that this combination of having engineering data, documentation, operation data in the structure of one digital twin is really the revolution, or can make the big difference for production of the future. We're talking about the life cycle, but also the integration, the vertical integration in a production, meaning device manufacturing, delivering their digital twin to OEMs, delivering their digital twin to end users, will make the big impact. So value creation, efficiency, and cost savings are reached within the value chain by exchanging and integrating all products along the value chain. And Aas is making this possible. What's the projects, the developments for today? We already have seen the package for Dr. Song presented this one, and this stands as a symbol how we are working. This is open source software. We put this open source software just now on our top level project on Eclipse Foundation. We have initiated the Eclipse digital twin top level product in the Eclipse Foundation. We are running our own GitHub open source repository. You can think about it like this. Eclipse Foundation is for future industry-ready projects. Our GitHub repository is for the information models and experimental projects around the Aas. So we are really happy, I already mentioned it, that we have the first Korean project in our GitHub today. On the other side, we are trying to integrate all existing standards. So we are not trying to define the world new, but we are using all existing standards, automation ML, E-class, OPC UA, to mention just a few of them. We are working on the integration of all these standards. So for example, E-class is a really important repository for the properties, but also IC CDD, for example. OPC UA, of course, as the architecture of the production floor, is a really important standard to be integrated in the future seamlessly into or with the administration shell. From use cases to information model, for us, it's really important that we are discussing about use cases and developing from the use case towards the standard. So we have started to have top 10 use cases. We have 3 clusters for these use cases: global impact, smart manufacturing, and asset compatibility. Within global impact, we try to present, or we are presenting that the asset administration shell can be a huge step towards sustainability. I already mentioned the digitizing documentation, but also for traceability, transparency, and decarbonization. So we're working on projects where we can show, for example, that you can integrate all the information about a product, meaning the different components of a product, the materials of a product, into asset administration shell, and using these information, for example, for the recycling of a product. If you exactly know what's inside the product, you can the recycling process can be much more efficient to get these materials back from existing products, recycled products. And also decarbonization. We are working on a project which is called product carbon footprint, where we are presenting how AAS can be used to track decarbonization along the value chain, meaning from a screw, from the iron of a screw towards a control cabinet, and how you can track all the different footprints of all the components going into a control cabinet, having the carbon footprint of the whole cabinet. Another good example is the energy monitoring of a production, which we are hope to present on the Hannover show in June, showing that how the Aas helps to have a general energy monitoring on a production plant of Volkswagen, for example. Going to smart manufacturing, these use cases are presenting how the Aas supports advanced manufacturing, product as a service, and high performance time to market reduction. And our use cases on asset compatibility are presenting the opportunities you get with Aas to have interoperable products. We have great use cases there from where we started, where we were discussing how is it possible to make plug and produce for sensors for drives, and we have great demonstrators there. Also will be presented on the Hannover show. Looking at the real use cases behind, we have on our cluster a global impact, the digital nameplate, product carbon footprint, collaborative condition monitoring. Gaia X is playing a big role in this use case as well. On smart manufacturing, we have real life examples, and we're happy again to have the Korean Aas-based pilot plant there. Was an inspiration for the colleagues of Volkswagen. As I already mentioned, we have a real life application at Wittgenstein, a small middle-sized company in Germany for gears and drives. We have Lenses asset management, a drive manufacturer, Stahl, a digital nameplate, and really interesting applications for the nameplate in process industry from the colleagues at Stahl. On asset compatibility, we have the use case asset onboarding, open industry 4.0 sensors, and the drive demonstrator showing different scenarios made possible by the combination of OPC and the asset administration share. Coming from these use cases, we are creating the needed information models called submodels for these use cases. So this is the idea, having the use case from the use case to the standard. We are defining right now 16 submodels. You can see the list of these submodels on our webpage. IDTA is offering this agile platform to bring in all these submodels to make them public. And we guarantee within our process, which I'm going to show on the next slide, a certain quality certification for these submodels. So submodels from IDTA getting into a quality process where we certify and guarantee that these submodels fit with each other and fit within Aas. So maybe as a vision, we are talking about a digital product passport, which is right now within the European regulations, and maybe a vision how Aas can develop in the future. I was talking about the process. Just for your knowledge, we have set up a process how information models are introduced into IDTA, how we set up working groups, how to work on these submodels. It's kind of a standardization process we have here, and how we publish these submodels. As I said, we publish everything open and for free on our open source platform on GitHub, so everybody can use it. So we need to lower the barrier for using AAS and having the matching submodels available. AAS training, really quick. We have established a training program. We went to the expert, the colleagues who work in our groups, like Dr. Song might know some of these people. We went to our expert, for example, to ABB, to Festo, Bosch, and SAP. We made interviews. We asked them, can you provide your knowledge in our training program? And we have set up a two-track training program. And we are happy to work on a joint training program in the future. As I said, we had just exchanged the contents of our training programs. It would be great if you have an international approach also on this. My last slides, forming the digital twin ecosystem. And really happy not only having Korean members with Nestfield and LS Electric, we are also happy to be in the process to sign an MOU with Cosmo. Thanks to President Park, we're going to have a signing ceremony. We are just planning about it. COVID is also a little problem there, but I'm sure we're going to find a way to have a ceremony on signing this MOU. On this slide, you see the organizations we are closely collaborating and where we are multiplying the idea of AAS. We were founded by Platform Industry 4.0, the German Machine Manufacturers Association, the Electrical Manufacturers Association, and the IT Association. We already have signed MOUs with the Digital Twin Consortium. We have MOU with Open Industry 4.0 Alliance, Alliance Industrie du Futur, the French initiative, and E-Class. As I said, we are really happy to be in the process with Cosmo, but also Catena X and Gaia X as the big initiatives in Germany and Europe for the data ecosystems for the automotive industry and for the general data safe, secure data ecosystem. Thank you for having us here. If you have any questions, please write it in the chat. Please get in contact with me. I was really happy, as I said, to be part of this forum this year, and I'm looking forward to see the progress in the future forums. Thank you very much.
Thank you very much, Mr. Billman, for great presentation and introduction. I think he has mentioned very interesting topics. So we all know the AAS is digital twin. Then what's the difference between the former style of the digital twin and the new AAS-based digital twin? So that was really interesting idea suggested. So as he said, it used to be the one shot of lifestyle. For example, monitoring or simulation in a single phase, like single phase or one shot or one point of the life cycle was the past form. And then we made it into the digital twin. But when it comes to AAS, as he repeatedly said, it's all through the life cycle. So from the planning, designing, making, managing, selling, and all those processes. So it's a one single big asset when it comes to AAA based. So it starts from the planning to selling, and all these process inside the manufacturing site. And then if we build this, we'll be able to manage even after the sales. So that's the big difference between the past form of digital twin and AAS right now. So if you go to the IDTA website, you will be able to find many interesting information pieces. So you would be curious when we can use the digital twins, and you will be able to see many different digital twins. And if you have any question, please contact Mr. Make Billman after the forum as well. And I hope that more companies will join as the members of IDTA in the near future. Is there any question? I believe that it's time to have a break. It's currently 5:16 in Korean time, so we will have 15-minute break and we will resume at 5:30 in Korean time. So see you again after 15 minutes.
This is e-demonstration system of Asset Administration Shell, AAS, based plug and produce P&P in smart manufacturing, co-developed by Nestfield Ltd and Hanyang University. In the era of Industry 4.0, one of the key challenges is how to digitalize the industrial production. The Asset Administration Shell is designed to transform the asset from a physical world into a digital world. What is Asset Administration Shell? It is a virtual representation of all the information and functionalities of an asset. It provides a standardized communication interface for information exchange. It is an access point of information and value-added functions in Industry 4.0. Why is Asset Administration Shell needed? The purpose of Asset Administration Shell is to facilitate the exchange of asset-related data along the production system life cycle. The Asset Administration Shell will make all the manufacturing components interoperable to realize the autonomy of Industry 4.0. Adaptable Factory envisions a flexible factory where production lines can be reconfigured during runtime. Analogs to the plug-and-play concept for desktop computers. The vision of plug-and-produce use case is to enable plug-and-produce capabilities for future production facilities. Compared to today's traditional production, plug-and-produce makes a new production paradigm possible. If there is an error with the working robot, the production line will stop. Therefore, on-site operator will immediately plug out the error robot and plug in a new robot, which will connect to the production system and perform the same tasks. That is, new field devices or production modules shall be integrated into production lines with minimal overhead, thus greatly increasing the production flexibility. The AAS-based P&P demo system has a 3-layer architecture. The top decision-making layer controls the whole system running using a web UI. The middle AAS layer is the AAS platform supporting AAS information exchange. The field asset layer contains 3 type independent industrial robots and 1 turntable. This is the demo for showing AAS, Asset Administration Shell-based plug and produce in smart manufacturing. AAS plays the same role as the digital twin in smart manufacturing. Key characteristics of this AAS-based P&P system are threefold. First, each asset, for example, robots and turntable, has a unique AAS. Second, Asset information are digitally represented in the AAS. Third, AAS can communicate with each other to realize the P&P function. AAS is composed of Digital Factory Header, DF Header, Digital Factory Body, DF Body, and submodels. AAS is now under development as an international standard in IEC Project 63278. Asset information are stored as properties in the AAS submodels, and the AAS has a communication interface to exchange data with other AASs. This is the information model of the AAS for KUKA robot. The DF header contains basic AAS information. For example, identification of asset and identification of AAS. The ID is in a format of Global Unified Identifier. The DF body contains 5 submodels. They are 1. Index data item. 2. Property value statement. 3. Documentation. 4. Communication. 5. Pick and place. The pick and place submodel is an asset-specific submodel, which is designed for KUKA robot to store and exchange pick and place related process data. How to implement the AAS? First, we use Automation ML, standardized in IEC 62714, to model AAS information of the P&P system. Automation ML is an XML-based data format that is suitable for describing information in AAS submodels. Automation ML contains an instant hierarchy module, hierarchically modeling individual objects as internal elements. Second, we use OPC UA, standardized in IEC 62541, as the communication interface to exchange data between AASs. OPC UA is a machine-to-machine communication method, providing interfaces for data exchange between industrial assets. We adopt OPC UA client-server mode to realize the communication capability of AAS. By utilizing Automation ML and OPC UA, AAS realizes the P&P capability in Industry 4.0. The turntable is surrounded by 3 robots, designated as R1, Epson 1 robot, R2, Epson 2 robot, and R3, KUKA robot. The web UI controls the system operating in operation mode and P&P mode separately. When an operation strategy is chosen on web UI, the system will run in an operation mode. First, click the drop-down menu to choose 2 robots, for example, Epson 1 robot and KUKA robot, to operate in the operation mode. The turntable conveys an iron plate, and 2 robots, for example, KUKA robot and Epson 1 robot, will execute the pick and place task successfully on the turntable in the operation mode. Afterwards, Epson 1 robot and KUKA robot are executing the pick and place task on the turntable in an operation mode. Indicator lights of Epson 1 robot and KUKA robot are green, while the indicator light of the Epson 2 robot is red. Finally, real-time AAS data of robots and turntable are monitored on the web UI real system. Operation is synchronized with the virtual animation on the web UI. At this time, all indicator lights of the 3 robots turn to yellow, indicating the P&P configuration process among 3 robots and turntable. During this process, AAS of robots and turntable will communicate to determine the operation of corresponding assets. Now, KUKA robot and Epson 1 robot are working in an operation mode. Now, through P&P mode operation plugout, the Epson 1 robot plug in Epson 2 robot. Now Epson 1 robot is plugged out. Epson 2 robot and KUKA robot are executing the pick and place task on the turntable in a P&P mode. Finally, real-time AAS data of robots and turntable in the P&P mode are monitored on the web UI. Real system operation in the P&P mode is synchronized with the virtual animation on the web UI. In order to change the system to run in another P&P mode, click the P&P drop-down menu on Web UI to choose another P&P strategy. For example, plug out another running robot, the KUKA robot, and plug in the third idle robot, the Epson 1 robot, to proceed with the pick-and-place task. At this time, all indicator lights of the 3 robots turn to yellow, indicating the P&P configuration process among 3 robots and turntable. During this process, AAS of robots and turntable will communicate to determine the operation of corresponding assets. Epson 2 robot's status light, it turns green to signify movement. Now KUKA robot is plugged out. Epson 1 robot and Epson 2 robot are executing the pick-and-place task on the turntable in a P&P mode. The figure shows the sequence diagram illustrating the information flows among AASs. Following the diagram, robots and turntable can operate in accordance with the chosen P&P strategy. Initially, R1, R2, and turntable are operating in an operation mode. When a P&P strategy is selected on the web UI, it will be delivered into all the AASs in the AAS platform.
Next up, we have Anya Simon, CTO for LNI 4.0. And she's going to tell us about the AAS use cases in Germany. That is really interesting topic. And now it's time.
Okay, thank you very much. My name is Anya Simon. As Seung Ho just even mentioned, I'm the CTO for LNI 4.0. LNI stands for Labs Network for Industry 4.0. What I have prepared today for you is an overview of some use cases which we run in Germany. That is a really good mix of use cases and projects for the implementation of AAS. And therefore, first I want to give you a very, very short introduction of LNI 4.0. What is LNI? What is the main intention of LNI? Then I want to give you an overview of the project AAS Networked, where the general concept of the AAS has been validated, and where a network of different AAS demonstrators is building up. And here you are warm invited to join that network. I will give you an overview of the project Basis. The intention of this project is to develop, is to develop a middleware for the implementation of the AAS with a lot of components you have already heard today in previous presentations. Then I will give you an overview of the project collaboration condition monitoring, which is running an AI real lab of a smart factory, OWL. After that, I will come to our own project, an LNI project, where we are going to implement an asset administration shell in a brownfield. And here we have collected first experiences in a navigation guide, collected and summarized that in a navigation guide. And also we will present you the demonstrator, which we want to show at the Hanover Fair in June of this calendar year. Last but not least, I will give you a very short outlook and conclusion of my presentation. Okay, so then I will start with a very short introduction of LNI. LNI was founded in 2015 from the platform Industry 4.0. And the intention of LNI is to be a neutral and pre-competitive public and non-profit test track for use cases which have been and which will be developed in the course of Industry 4.0. Our intention is to make that use cases available for the businesses, for the companies, and transfer a lot of knowledge regarding the upcoming technologies, regarding the use cases, the application of the use cases in your companies to the small and medium companies. We are working very strong together with our colleagues from the Standardization Council, Industry 4.0, as well with the other associations like the EDTE. You have heard it before from Mike Billman, and also the other national and international associations in Germany and in the world. Please keep in mind, LNI is not a standardization association. We are a test track to test upcoming use cases, upcoming scenarios for the Industry 4.0. LNI 4.0 is orienting at the Vision 2030 for Industry 4.0, and Stöckel Pukal mentioned this vision already in his greeting speech. And following up of these three main pillars like interoperability, autonomy, and sustainability, LNI has broken down some action fields for own purposes, for own development, and for own content. And starting on the left-hand side, for sure, machine interoperability is the basis and the network of all our new upcoming Industry 4.0 scenarios. We are talking a lot today about machine interoperability using the Aas. Next one would be the human integration, because also human play a very important and major role in the upcoming Industry 4.0 scenarios. We have to handle with data management and analytics across all the upcoming technologies. The circular economy is an upcoming topic which is now very much or more valid than in the past in regards to how to save this world, how to save resources, make them available in the circular economy, and how could also an asset administration shell could support that. And last but not least, the upcoming digital business models play a big role for the future situation and future participation in a digitized world. And therefore, all these 5 action fields are our own, and we try to drive and to provide and to offer test tracks for that. We try to provide some example scenarios for that, and warm invite our communities to join these test labs. We have a great network in Germany. This slide might be more interesting for our German participants, which we have hopefully in that call here. We have a lot of different labs for different technologies and with different purposes in our network. Under column R, you can find a lot of own customer experience centers, own labs from companies, which providing a neutral presentation of technologies and products without to be a sales event. On column B, we have a lot of different academia labs where new technologies have been and will be developed and will be mapped and mirrored to our companies, how the new technologies can be applied to our companies. And last but not least, we also serve some own test beds within LNI. And as you can find here on the very first, the asset administration shell test bed is a very important one because that is driving our machine interoperability. On the next slide, I will give you an impression of our international connections and corporations, because mainly LNI is the target region of LNI would be Germany, but you can imagine all over the world the different questions, the different tasks in regards to Industry 4.0, how to implement this and how to run into a digitized world are always the same. The questions needs to be answered always the same. The experts working on the same topics, on the same details, and therefore it's more than worth to connect all the networks together, to connect all the different experts together and exchange experiences and leverage the results of the tests. So we have a very strong network in Germany themselves with a lot of comparable LNIs in the Netherlands, in Italy, in Romania, and so on. But we have also a great network with the main player and key players for digitalization in the world. And that means we have a good network to US, but also to our Asian colleagues and also to our Indian and Australian colleagues. And for instance, with our US colleagues, we're talking about the Aas and the machine profiles. Very interesting to see the approach of the US. We talked with our Chinese colleagues about TSN, time-sensitive networking, the timestamp of shop floors, which is crucial to provide in a digitized world and connected world. We talk with our Japan colleagues about edge management and edge ecosystems. We talk with Australia also about the asset administration shell and machine profiles and a very, very big partner for the asset administration shell and a very mature partner, so to say, for the asset administration shell are our Korean colleagues, because the Korean colleagues really going to implement test demonstrators. They have presented that in the morning from one ZEOC from Nestfield. You have seen some demonstrators for the Aas, and now we are running in the next step. We are coming to a next level of cooperation where we want to connect also the demonstrator across the world in an international network. And the intention of all that would be to exchange test experiences, to exchange trainings, what also Mike Billman mentioned before, and to make a knowledge transfer about this upcoming technologies for Industry 4.0, as the Aas is a main important part of that. Okay, that was a very short introduction of LNI. If you have some questions, you can contact me. You will get my contact information together with that presentation here. Now I will come to the first project I want to present you, the Aas network. The intention of this project was to break down and specify the general concept, the theoretical concept of the Aas to a lab, in a lab environment, and also to real demonstrators, break this concept down. And in the course of this concept, there have been identified and developed 3 types of the Aas. Also, one ZEOC mentioned that beforehand. We have a very first type that is also called passive Aas. It's like a file for exchange with other shop floors, with other partners in the value chain. And the second type is the reactive Aas. Here the Aas and the shop floor will be connected via APIs to subordinary information models. As you can see here, you can reuse the installation from the type 1, also in the type 2, and have to add some more installations, components for the Aas for the type 2. And in the type 3, we come to a level where the shop floors are building up some digital business models where they are going to be active. Therefore, this asset administration shell is called active. And the intention of this type 3 is to drive an active interaction between different shop floors, different asset administration cells, in regards to a business model where tendering, where allocation of production steps and so on can be arranged. And therefore, on top of the components which you need for type 1 and type 2, you need in type 3 and so-called AES agent for the interaction and dialogue of the different AES. The good thing is you can start with the very first type, is a type number 1, and you can gradually update from one type to the other your AES without any new installations you need here. Despite of this additional components you need for the next level of the type of the AES. And that is a very good construct which also supports small medium companies and also some other installations around the AES. And therefore first you need to think about, okay, how to integrate this AES in your shop floor, in your company. Another task of this project, AES network, was to connect demonstrators together, different demonstrators, first in Germany, to connect the different demonstrators and to play around what is needed for this connection of the demonstrators, also what is needed to exchange different AES from the demonstrators, and that is up and running. It's a good situation, it's a proven situation, and therefore the next stop or the next step would be to bring in some content in that network. That means if we want to realize in future digitized digital business model where the different shop floors can manage and allocate different production steps between each other and can make a tendering, might it regarding the capacity of another shop floor, might it regarding a special functionality which is required from a product, or might it be also in negotiation or tendering in regards of prices. This is also the next step in this project AES Connected, where this negotiation between and tendering between the different shop floors, the different AES has been established. For that, there was a development of an Industry 4.0 language required. And currently the status is that this will run through the different demonstrators and first experiences are collected with that. And they are on the way to widen up their network with the different capacities, with the different functionalities they want to connect here. And that brings me to the next and last slide for this project. You have seen this slide also already from Von Seok. The next step would be to extend our network of different demonstrators from Germany to an international network. And the very first address for us would be the Korean demonstrators, because the Korean demonstrators are very mature. They are up and running. They have a lot of experiences, and therefore it's good to have such a mature demonstrator to connect that to our German network of demonstrator. And that would be the next step to a connected manufacturing shop floor across the world and build up a basis for upcoming digital business models where different production steps could be tendered and could be managed between the different shop floors on an international basis. And we are very much appreciate that the Korean colleagues from Westfield will join our network here, and we start with that within the next week. Okay, that was really a very short snippet about that AES network project. If you have some more questions, Professor Christian Dietrich would appreciate to get your questions and to drive that network furthermore. Coming to the next project, that is the project Basis, which the intention of this project was to identify first and then to provide different components which are needed on a regular and standardized basis for the implementation of an ANS. You could imagine that you always run in the same questions, what is needed to implement an AAS, where to get the different components, the different pieces and parts for that, and therefore the project basis concentrated first how to develop a middleware between your existing infrastructure and existing applications in your existing shop floor, and how to connect this to an AAS type of what we have seen before, and how to connect that to a type of the AAS and to realize an AAS. And this middleware is really concentrating on this very generic architecture you can find on the right-hand side here. And following this very generic system architecture, there have been developed and there have been produced different components, which some of them already have been implemented in the IDTA suite, where you also can download some of the components which have been already released there. Okay, and it's worth to look at this because a lot of questions and a lot of development you don't need to do from scratch onwards. You can use some of these components here of this, I call it middleware suite. The name is Eclipse classes. You can use this components, but don't have to use all the components. It's belonging to your individual situation of your individual AAS implementation, what is needed from your point of view, what is needed to implement an AAS in your individual situation. And the colleagues here are constantly working on the different components, constantly developing next components or developing the existing components to a next level, and they are very much interested in to get your feedback about your real installations in your demonstrators. And this project is also very connected to the IDTA colleagues, and therefore you don't run into different directions here. We are all connected with each other for that. Okay, that was a project basis, and if you have some more detailed questions, very much detailed technical questions, and how to get these components and so on, Mr. Thomas Kuhn would appreciate to get your questions here. And you can also find in these links below some more information. Okay, coming to the next project, I have to look at my time. I have to speed up a little bit. The next project, it's regarding the data management in an AAS environment and the data management in regards to collaborative condition monitoring. And this project runs in a real lab of the Smart Factory, OWL. You don't need to learn this word because OWL is a region in Germany. And therefore, if you keep in mind that is a real AI, real lab of a smart factory, and that would be enough. And collaboration condition monitoring was a use case here. Based on an existing AAS implementation, the question or the main target of this project was to answer the question how collaborative condition monitoring could create and can create some value added in a cross-company cooperation, in a situation where companies connected together via an AAS and collaboration, condition monitoring and data management behind of that could create some additional benefits and crucial benefits which would not be able to create it without an AAS installation. And what they used for that, they have multilateral data sharing. They have to share and form for time series Furthermore, they are based on the exchange, cloud exchange basis from Gaia-X. They are using Gaia-X Federation services. That was very much helpful to get connected via the cloud environment with this Gaia-X Federation services. They're also using not only the connection from Gaia-X, also they use the Gaia-X identity and trust services from Gaia-X. That was also a major and crucial and critical topic which needs to be considered in this project setup. And also the usability of data, the content, the usability of data, and how to discover the data, how to manage the data, and how to use the data in the different companies. For that, they have also used some services from Gaia-X catalog. And the results of that project are summarized in very short words. You can see it here at this slide. The Aas was an enabler for the cross-manufacturing data exchange, the data exchange between different cross-manufacturers, and the Aas reduced the data engineering efforts on a very high degree. That means you don't need to think about each and every data engineering. A lot of different tasks and tools which have to be run in the data exchange are covered by the Aas, and based on the Gaia-X Federation services, there was really a trusted data space for this Industry 4.0 given. If you have some questions regarding that project, then Mr. Michael Jochem would be happy to get your questions here. You can find here some more information of that project. You can imagine that is only an overview, but I can give you in this short minutes here. And if you have some more detailed questions, then please contact Mr. Jochem or look in the links of this slide here. Okay, last but not least, I will come to an LNI own demonstrator, where the intention of this project was to bring and implement an Aas in an existing brownfield, in an existing shop floor. And we started from the standpoint or from the viewpoint of the existing shop floors, and we have a lot of good managers from small and medium companies in our circle here. And the actual and well-known structure of existing companies are like this. You can find on the left-hand side. We have allocated our different assets to the different levels with different tasks of the levels, what needs to be managed at which level here, and coming from the field level up to the over the control level, management level, and the enterprise level, but also not forget the products, please, which are the outcome of the companies, where the companies earn their money with, and also the products have some requirements for the Aas. So, and now how to implement an Aas in such a complex structure of a company, because the Aas presents not only the application of the machines and devices in the field level, they really present also shop floors. They are going to present products. They going to present also some tools in the shop floors, as well brain and software assets. And there are a lot of other things which an Aas can present. And the question would be how to bring this Aas in this complex structure of the company. And therefore, the Aas will touch all levels of your company, not only one. The shop floor, the control center, will touch all the levels of your company. And therefore, first, you need to answer the question, why you want to integrate an asset administration shell. What is the target? What is the scenario which your company will prefer to integrate an Aas, and which role will your company play in the future with the Aas? And then the next question would be what, how is a very valid approach to integrate this Aas in your existing brownfield in your existing company, in your existing shop floor, without destroying all the things which are already running. And the next step after that approach would be, the next question would be, what needs to be done to implement the Aas at each and every level here in a very proper way. And this is what we are running in our project in LNI. You might have seen that interesting picture here. I will not run through each and every topic here. You can see at the slide, it's a picture. This is our shop floor. It's in demo center. It's in shop floor. In the end, there will come up this nice pens. Looks a little bit simple, but the shop floor consists of very different machines from very different providers on a very different year of construction with a very different degree of maturity. That means we have some very simple analog machines there. We have some smart machines there where already some sensors and connectors have been implemented, and we have some intelligent sensors here, machines here. And that means that is a very, very similar and very presentable, comparable situation you will find at each and every corner in your businesses, that you have a wide mix of different machines where this asset administration shell should be served as connector on top of that. And therefore, it is really very interesting how to run this asset administration shell implementation project. What is the first step? What will be followed? What is the major important step? And which question we have to answer here? And we decided to run 6 application scenarios. First one would be to bring all the machines on a level that they can be connected. Also the analog machines, without any connection, it's not possible to have a networked shop floor. Then to think about in the second step about the communication, which is the best one for the shop floor and the machines here. Third one would be to think about the requirements from a product, and might it be this nice pen, could also be a gas turbine, if you think very big, could also be a gas turbine, and which requirements from this specific product will be done to the shop floor. Next one would be, of course, we are very much looking forward to be a connected part of the project Aas Connected, what I have presented beforehand. Then we think about which additional information and benefits can an Aas bring to a control center of such a shop floor. Are there any benefits? Are there any additional functionalities, and how these additional functionalities can be used in a control center? And last but not least, we want also to run in tendering a very, very first and simple digital business model, the tendering of this nice graver, which you can find here at this pen. And yeah, we are in the course of this project here, and we have a lot of different managers of small and medium companies in our project here, and they ask always the same question: Anja, what is needed? Can you please summarize a navigation guide for us? What is needed in which level, in which step to implement the Aas on our entire company? And you can find here on the right-hand side a navigation guide for that, starting with this question why and what, followed up to decide which type of Aas you want to integrate. Then look at the existing systems as is situation in your shop floor. Present all the tools which are required to touch by the Aas. Then look at the assets, the machines and the assets you want to include in the asset administration shell implementation. Then what's about the existing network and what could be a next step for a network in your existing brownfield or shop floor, which requirements coming from the product to your implementation in your shop floor, then to break down and bring in which specific components you need for the implementation in your specific brownfield for the specific implementation. And then after that, think about how a networking between your shop floor with other shop floors could be realized. And last but not least, that is a very commercial question. What needs to be done by yourself and what can be bought from speeds which are already available for components for the Aas, also the make or buy question. What is really already available? And you might remember on the presentation of Mr. Park, he has told a lot about ecosystems, a lot about different platforms, and that is in regards to that to make a make or buy decision. Okay, there are a lot of different detailed questions behind this main questions here. And if you are interested in, then please contact us. It would be too much for today to run all through these detailed questions here. The last topic I want to point out, and also one CEO has mentioned that we will present this tendering of this graver of this on this pen on the Hanover Fair in June of this calendar year, and the tendering between two lasers. One laser will stand at the German booth, which is able to provide some Latin letters here, and one laser would be placed at the Korean booth, which would be able to provide some Korean letters at the pen, and this is what we want to present at the Hanover Fair. And you are warmly invited to visit us. We are both the Korean and the German booths are in hall number 8, and you are warm invited to visit us at the Hanover Fair. Might it be in person or might it be also online? Okay. So if you have some further questions about this Aas in brownfields, you can contact me and also my counterpart in Hanover, that is Dr. Michael Rehe, and we would be happy to get your questions and your experiences for the installation of an Aas in brownfield. Now I come to my last topic, outlook and conclusion. And if you look backwards through all these projects, and especially also through the project how to implement an Aas in a brownfield, you might recognize that the Aas is not another additional tool which you are going to implement. It presents complete new entry point into the new digitized world, into the future of the Industry 4.0. And therefore, you need to ask the question what you want to leverage with that Aas, why you are going to implement that Aas in your company. After that, how could be a very good and proper approach for the implementation of in your company. And last but not least, what are the details and the crucial topics you need to clarify for your specific brownfield, that the Aas will fit the best with your company. And therefore, you are warm invited to become a part of our Aas network. Contact us all. Might it be Mike Billman from the IDTA, might it be our Korean colleagues, Seung Ho, they have a strong network about the Aas, might it be also Jens Geiko, which will follow with the standardization lecture for the Aas, or might it be myself with the test track, where we are going to offer a lot of tests and test labs for the Aas. And therefore, thank you very much. Now I have done my presentation, and you will find my contact information at this slide here.
That was really interesting, Anya. Thank you. And I can see we are facing pretty much similar issues between Korea and Germany. And factories want to bring the AAS, especially in the case of the brownfield. Dr. Song talked about the repository and the reference model. For example, we have the reference model. Once you create a reference model, other robot companies can take that AAS. They do not have to make it from the scratch because the reference model is available and they can develop their own AAS. That is why Korea is working on reference model and repositories. In Germany, in the BASIS project, they have a hierarchical level, and in hierarchical level, for each of the asset, they have the reference model, and that's really structured. I can see Korea and Germany are concerned about the repository management, and we have opportunity for future collaboration. She also talked about brownfield. Many companies say we are outdated factories, so we want to put the AAS, how we should do it, and what is the benefit of the AAS. There are lots of questions. Probably Anya got the similar questions from the local factory owners, probably. The nice navigation guide was presented. And this is something we must refer to. I sincerely hope that the Cosmo can refer to the reference guideline and the navigation guideline and customize that in accordance with the Korean conditions. Because in Korea, we have lots of brownfield and lots of brownfield use cases. We should be able to come up with a new solution. That's something that we need to collaborate in the future. Thank you very much for the interesting presentation. Thank you very much, Anya.
So next, we're going to listen to the next presentation from Dr. Jens Geiko, who is the CEO of SCI 4.0. And then Doctor will talk about the perspective of AAS standardization in Germany and IEC.
So I'm going to talk about the perspective of AAS standardization in Germany and internationally, mainly at IEC level. Already at the first German-Korean Forum on Industry 4.0 Asset Administration Shell back in October 2020, I had the honor and the pleasure to give a presentation. At that time, we have been very much in the phase to explain about the basic principles of asset administration shell. Seeing today's presentation, we can see a huge progress, and I'm very happy to be part of this very successful cooperation. Again, back in 2020, I gave in my last slide an outlook on the next steps and ongoing activities. And at that time, I mentioned that the challenge of the next month will be the extension of the standard series for the AAS, this IEC 63278 series, extension of repositories for semantic properties, and modeling of aspects of assets, so definition of submodels, and also the mapping of different technologies, and also other challenges. So today I'm going to talk about the progress in these areas, and you will see that a lot of progress has been made, but still a lot of work has to be done. Starting with the standardization on the asset administration shell itself. So we have currently two developments at IEC TC65 level, and I'm pretty sure you are very much aware about these developments. Just 2 months ago, a new work item proposal on the part 2 of asset administration shell has been launched. This is on the information meta model. The closing date for the voting will be next month, and we are quite confident that this will be successful, and then soon we can start this project. What is it going to be about? So the part 1 of the asset administration shell standard defines the basic principles and the structure. And the part 2 will describe the information model, and this will allow also to create data mappings to suitable technologies. But also you can see it here highlighted, this document will not describe the mappings itself. But as Mike Billman already stated out, there are ongoing activities, for example, at the IDTA, and also there a lot of cooperation, for example, with OPC Foundation and Automation ML organization. So here this standard will describe the basic principles and the foundation for this, and then the work will be done at other organizations. So I think this is quite good cooperation here we see on all levels. Second new project is the planned part 3 of the standard series for asset administration shell. This is on security provisions for AAS, and also closing date is next month, and also here we are quite confident about this project. So this part aims at secure and interoperable exchange of information, which is of course a quite important aspect. And also the project will cover the 3 central targets of security, of integrity, authenticity, and confidentiality. And here it will describe the measures. Here I have a picture taken from this new work item proposal, and it shows that the basis for this project or for this standard will be the requirements in IEC 62443 series. This is a standard series of IEC TC65 dealing with the so-called shop floor security. So we have ISO IEC 27000 series, mainly for general security provisions, and this series for shop floor security. And this is the basis to derive the requirements specifically for AAS. You can see here also graphically which parts will be covered by this part 3, so on the submodels, on the interface and the substructure. But there are also aspects which are out of scope of the standards, like, for example, specific implementations or AAS user applications. And also some topics to be discussed. Well, the general structure of AAS is well known, and today we have already seen this or a similar picture, so I can keep this very short. One picture here also taken from the draft of IEC 63278, so the general structure of AAS describes the scope of this standard series. This is the gray box. Beside the scope, you can see there are a lot of other boxes outside of this gray area. So that means we need a whole ecosystem. And one important element is here highlighted in red. These are the dictionaries and ontologies. And these could be implemented, for example, via the IEC Common Data Dictionary, or also consortia-based dictionaries like eClass as a very widely used dictionary in the area of automation. So we can say that dictionaries play a central role for semantic interoperability. And during the first forum we had, I announced that we have started some activities to harmonize the IEC CBD and also eClass, or to work on this one. And this is now the SOAP project called COMDO, and I will explain a little bit on this project. The basic idea of the project was based on the finding that we have 2 dictionaries or databases which are complementing each other, and they are based on the same foundation. So both dictionaries are based on the information model as it is defined by IEC 61360 and the corresponding ISO standard. So they have the same origin, they have a lot of similarities, but there are also some differences. These are differences in details of the implementation. But also there are differences, of course, in the content, because it makes no sense to have the same content in two different dictionaries. But today for the user, it is not easy to use both dictionaries at the same time, because due to these small differences in implementation, always you have to see and consider what is the source of a property, and then you have to process this property according to this. And this is, of course, not a very good situation for information processing. And this is a kind of barrier for interoperability we aim to achieve. So therefore, different approaches, or the question came up how to achieve a consistency among these dictionaries. Consistency here means it's not aimed to have both the same content, but to both dictionaries use the same implementation, or this are implemented in the same way, and also content which is available in both dictionaries should be the same or as similar as possible. So there should be no contradicting definitions in the two dictionaries. A first approach for harmonization between eClass and IAC CDD has been made more than 5 years ago. That was a project called DMAP. And this DMAP project aims at mapping content which is available in both dictionaries in principle, but not in detail, so to do some mapping. Here some achievements have been done, and some success was achieved, but some issues found by the test mapping, and this could be solved only partially. So findings have been a mapping from one dictionary to another one is possible, but not automatically. So it is manual work to be done. And especially it's manual work to be done by experts of these dictionaries. Because if it is just simple work to be done, then it can be automated. But here you need the precious time of experts of these dictionaries, and therefore it's not a feasible approach for the long term. And also one finding was that, of course, both dictionaries are dynamic. So that means they are changing all the time, more or less. And so once you have finished in the mapping exercise, then you can restart again because some changes have been done. So therefore, we gain precious findings out of these projects. But the central finding was that this approach is not feasible, so we need a new approach. And this new approach was to say we have to look at the customer requirements and say we need a single common data repository. And then we started this project and called it COMDO, and COMDO stands for One Common Data Repository. And here it is illustrated, but of course very simplified. Means we will probably have one common database with one central interface for content delivery and usage. And within this, you have two different sectors, one for the eClass data and one sector for the ISO and IAC sector. Here I say explicitly ISO and IAC because ISO is also developing content for CDD. It's not yet published, it's still in the development phase, but in the future it will be available. And therefore also ISO decided to join this project. So we started in 2020 to discuss about this. And in December 2020, so shortly after our first forum, MOU between IAC, ISO, and eClass was signed. You can see this was also distributed in IAC Standardization Management Board. And we have, of course, participants in the project from eClass, from IAC Central Office, from ISO Central Secretariat, but also we have experts joining from DKI and DIN. And also we have international experts from industry for CDD and eClass. I have to say mainly from Germany, but also from France. And coordination is done from Standardization Council Industry 4.0. So the benefits is, of course, to have an integration of high quality content created and maintained by the different technical committees from ISO and IEC, and then to provide this content in one common data repository. So for the users of these repositories, there is no need to decide where to download the content because it will be a kind of unified access. And also there is a potential for harmonized content, which is indicated here. So once we identified and said we have content which is the same or more or less the same in the E-class sector and in the IEC or ISO sector, we can develop harmonized content out of this. And here this arrow indicates it's also possible to update this harmonized content. So once the harmonization is done, then we can update the harmonized content, and here we avoid that the content diverges again, and we have again to do a remapping. So the analysis phase is finished, and now we started the implementation phase that will be done in 2 phases. The first one is implementation of the, or to provide the content as it is today via this one. And the second phase is to have the possibility for this common content, which was shown in the green area on the slide before. So we are right now in the phase of preparation, of detailed planning for the implementation, and hopefully within this year we can provide the implementation of phase 1. This is again a slide I showed in October 2020, where I said we need a seamless integration of the semantic properties. So we have on the one hand standardized properties from ISO and IEC, we have consortia-based properties from E-class, and also probably we need proprietary properties. And we think the project Combo will be a very important activity to fill this picture with life, so to make this happen. So here we could achieve good progress. Next one I'm going to talk is about the modeling of the AAS submodel templates. Mike Billman presented in his presentation the activities of IDTA, which is very important for the ramp up, and to have also a central repository of the submodel templates, because otherwise it will be a mess for the users to find the submodel templates if we have no central repository for this one. But nevertheless, we decided, or there is a need also from the users to have some submodel templates in a standardized way. And as I've shown before, the submodels refer to the semantic properties as defined in E-class or IEC CDD. And this is typically done here with these so-called IRDs, which indicate here the number, and based on the prefix, this 0173 and 0112, you can see whether this is content from E-class or content from IEC CDD. And here we have a strong relation to this, and we identify 2 ways of references which are possible. The first way is that we have a separate description of a submodel template with all the elements which are in a submodel template, and each of these elements indicates via an IRD to semantic properties. So I just see this is in German, but it's more not to read about the content here, it's more to show the principle. So we have a dedicated description of the submodel template, and we have here then the different references to the semantic properties. And this is the first possibility. The second one is also to encode the submodel template directly within the semantic dictionaries of E-class or IEC CDD. And here you have the submodel template, just the basic information you have, and then you have a reference to the dictionary where you have the class with all the information in. And both ways are possible, but to implement these both 2 approaches, also some preparation work is required. And one preparation work is also to enable so-called database standards for IEC CDD, and therefore just recently, just 2 weeks ago, a new work item proposal was launched at IAC Subcommittee 3D. That is the one responsible for Common Data Dictionary. And it is about a database standard as part 7 of this IAC 61360 series. So this will be a standard published in database format only. And there is already an implementation in the test area of CDD. So if you are a registered user or expert of IAC CDD, you can see it already in the test area, but for normal user, it's not yet visible. So how could this look like? So will have this IAC 61360-7 some general items in this database structure. Then we will have an area where you can have asset administration shell, or more precise submodel templates. And then, for example, you have a dedicated submodel like a digital nameplate. Digital nameplate is one example of a submodel going to be standardized internationally, because nameplate is something which is also required by regulatory, by the authorities. And here we've seen, or industry says it's beneficial to have this as a standardized submodel template from IAC in that case. Sorry. So this new domain will be published, as I said before. It is already implemented in the test area, and in the test area there is already a submodel digital nameplate implemented, but this is really a first test to show the feasibility of implementation. So please don't rely on this, because there will definitely be some changes. But here on the right side you can clearly see there is a list of properties having the different properties like manufacturer, type of product, serial number, year of manufacturer, and so on. So all this can be stored here and referencing to semantic properties. So finally, I conclude and can say AAS shall or will become international standard, developed by IAC TC65 Working Group 24. But here we have a very good cooperation also with Korea, and Korean experts are very active in this group. So I'm pretty sure you're very aware of this. Also, we have activities at the IAC Subcommittee 65E, Working Group 2. They will start a project very soon for a dedicated submodel template on the digital nameplate. So this will be launched quite soon. But before we can implement this, we need also the database structure. And here it is done at Subcommittee 3D to prepare let's say the infrastructure for this to have database standards. So as I said, this is under Belut now, this new work item proposal. A project team is already established. So if you're interested, you can contact the convener, or you can contact me. I'm happy to establish the contact. And also there is an activity plan to publish a white paper to model the semantic of data of an AAS with elements of CDD, because there is a similar paper is available for E-class, and now it's considered to have the same for CDD. As I said before, it will be very similar, but not exactly the same, because there are some small differences which need to be considered. But we think the white paper from E-class is an important step, and also the similar white paper for IAC CDD will also help to ramp up the application of asset administration shell. And with that, I come to the end of my presentation, and thank you for your attention.
Thank you very much, Dr. Jens Geiko, for your presentation. So there are actually some experts who are skeptical about AAS in Korea yet, because AAS is not an international standard yet. And when will it become the international standard? And then will it become the international standard? So they are kind of skeptical questions. In Korea, but Dr. Keiko clarified about those questions. So part one is about to be completed, and part two, part three, and part five and so on will be added in a really near future. So whether it will become an international standard or not is not a questionable issue, I think. And then he also talked about the E-class a lot as well. So in Korea, we look into the dictionary to find out what I want to explain in Korean and in English and etc. But in the Industry 4.0, machines and machines need to communicate with each other. Then among them, they need a kind of terminology and meaning of that terminology, right? So we need to build that first of all, then after that we will be able to standardize. So CDD, the common data like dictionaries are now under development, just like E-class, CDP as well. So we need to secure that first of all, then after that, just like we have conversation among people, machines will be able to have conversation. So we can say that this Komdo is a really important project. I am sure that this will be really important project. So there are a lot of content in English and in German, but not that much in Korean yet. We asked to be included in the CDD, but if we are included, then all those the content should be translated into Korea and uploaded in the database. So we need to do it, but it's going to be a very massive project. So I'm sure that the promotion team must work on this later on. So that was the presentation by Dr. Keiko.
Thank you, Dr. Daiko, for the wonderful presentation. Last but not least, we have Professor Lee Chu-yeon. The topic is AAS reference model and the application case of the injection molding machines. Probably you may be wondering how we can create the AAS model. And Dr. Lee will tell you the story based on the injection molding and how the AAS can be built for injection molding machine. Okay, Dr. Lee, please understand that I'm joining here online because I have a lecture today. Today, I'm going to tell you how we can build the AAS reference model, and we have applied that in the testbed. Let me tell you a little bit about the AAS reference model. And this is the injection molding process for your information. Injection molding is a process of injecting melted plastic raw material into a mold and applying the right level of heat and pressure to create a certain shape. You can see hopper, nozzle, and mold. And at the bottom, you can see the 5-step process starting from injection to ejecting. Hopper is where you put the plastic in. The heater is giving the heat to melt the plastic. The plastic will be melt and is going to be put into the mold. That is the process called injection. And after we give some pressure, and that is holding and packing. And after that, there will be cooling after that. This is going to be the sequential process. When the cooling is done, the measuring of the raw material is done on a parallel process. This is the typical process of injection molding. Let me play a short video clip.
네, 그냥 진행해도 되겠습니까? 좀
지금 그 아까 그 자료는 그 여기 당사분들이 다 다운로드 받았을 거고
네네.
저기 그 영문 자료로 발표하는 게 좋겠어요. 왜 그러냐면 독일
And probably you can play an English version.
알겠습니다. 잠시 그럼 공유를 중지하고 제가 영문 자료로 다시 발표를
Wait a second, please. I'm going to share the English version rather than the Korean version for the sake of the international guests.
이 앞부분은 했으니까 넘어가고요. 영상부터 시작하겠습니다.
Let me play the video clip once again.
제가 앞에서 설명드린 부분을 잘 보여주고 있는 영상인데요. 사출 공정이 어떻게 이루어져 있는지
This video clip will show you how the injection molding process can be made.
일반적으로 플라스틱 원료를 사용해서 제품을
Usually, plastic is used. You melt the plastic and you create this kind of product.
나오고 있는 과정입니다.
With the mold, you can create this shape of product.
이거는 부분이고요.
This is where mold is located.
사출 기체의 대략적인 모습을 물론
And you can see the injection machine. Of course, the shape of the machine can be different. This is where hopper is.
히터 쪽에서 열이 발생하면서 이
The heater gives the heat to melt the plastic.
여기 스크류가 이제 그 중심에서
There's a screw.
밀어내는 역할을 하게 됩니다.
It will push down the melted plastic to the mold.
보시면 이쪽으로 아마 이동을 하면서 점점 더 녹는 모습을 보실 수 있고요. 이렇게
And you can see the plastic is melting as it is moving to that direction. Now injection is made to the mold.
여기 금형 틀에 수지가 이제 이렇게 들어가서 차게 되고요.
You can see the mold,
그럼 이제 그 형상이 만들어질 때까지 압력을
and then the pressure will be given consistently, and cooling will take place here.
다음 단계, 다음 샷을 준비하는 계량이 일어나고
And the measuring will be made at the back end, and the final product will be created.
지금 보여드린 게 이제 사출의 일반적인
This is how injection works.
자, 그래서 이런 사출, 세부 공정으로 이루어진 이 사출 설비, 공정에 대해서 AES의 참조 모델을 만드는 게
And we wanted to create the AAS reference model for the molding machine.
다양한 유형들이
But there are various types of the injection molding. The motor, the driver can be different. There can be servo motor or the hydraulic motors. There are various types, and there are lots of sizes, large size, medium size, and small size. So the data attributes shall be different machine by machine, and we cannot make a single AAS. So we wanted to make a common model, and after that, for each of the type, each of the size, we will create a model specific to this type and size. We first create a common and generic model, and after that, we are going to customize model for each type and size.
1단계는 두 단계로 나눌 수 있는데요. 1단계는 도메인, 사출 성형 공정의 도메인 지식을 기반으로
First, we need to collect the domain knowledge about injection molding. In the second phase, we are using OPC-UA companion specification for the extension of the model. Because initially, we should have a reference model and reference information model.
이 사출 성형에 저희가 AS 레퍼런스
For the injection molding, actually, we did not have enough information. That is why we referred to some of the domain experts because there were not enough documentation available to us.
관련되어 있는 부분으로 확장하는
Of course, OPC-UA was providing some information, so we used the OPC-UA companion specification. Physical structure was first defined, and after that, the process data modeling was made. The first round of verification by experts was made. In the second round, OPC-UA model was the basis so that we can extend the property and structure, and there was a second round of the verification by experts. Currently, we are at the final stage of verification. These are the set of the reference data. And there is a CMS middleware system used by Ujin Prime. They provided this data, and FANUC, which is an injection device, has a linky data. And based on this data set, we analyze the data item and data structure. And we analyzed the data and we worked on the data mapping. We also collected some of the field data and analyzed the structure. The first round of modeling was made. This is the physical structure of the first round of model. Injection molding machine has injection unit and clamping unit. And you can see hopper, band heater, barrel, cylinder, screw, nozzle, and motor drive. For the clamping unit, there can be coolant, mold, and motor drive. I cannot show you all, but I will specifically show you about specific models for these three components. Asset was first utilized, and after that, we came up with submodel, collection, and property. Identification and nameplate, these kind of information were the various foundation we started with. Hopper is also important. This is where the plastic material is going in. So we got the operational data and material related information. The parameter set can be a part of the operation data, and as you know, for each of the machine, the configuration or the parameter information is really important. The same applies to this kind of injection molding machine. That is why we have a separate submodel for the parameter set. For the cylinder, we have submodel of identification, nameplate, and technical data and parameter set. For each of the asset, or each of the submodel, I put the identification. When the information is really important, I put the identification. But for example, there can be some consumable products. And in that case, we can put the identification information. For the cylinder, it can be consumable, but they are outsourcing that, so we have the identification number. The first round of modeling was made, an AAS model was made, and we got some comments from the experts. In the second round, we got the comments from the experts as well. And we are going to make a decision whether we are going to accept the comment or not. In the second round of modeling, we expanded the model. OPC-UA companion specification does not have any information about the injection molding machine. OPC-UA is just showing the plastic and rubber machine and also the compressor machine. And as you know, the extrusion is a bit different from the injection. So we were not able to use the extrusion model as it is. So we simply borrowed some parts of the extrusion model. We got the physical structure, and within the physical structure, we were mapping the data. However, OPC-UA companion specification, this kind of extrusion case, did not specifically reveal the physical structure. That is why we refer them as a reference to extend our model. For the injection molding machine, the first round is up until the controller level. With the OPC-UA, we added energy, operational data, maintenance, and machine configuration and log event. And also, we also mapped the properties based on what OPC-UA is suggesting. Especially in the case of the log event, we did not have this kind of the part. However, OPC-UA gave us a useful information, and they have a really useful set of the log data related components. Mode is really important. In the OPC-UA, actually OPC-UA has a mode, and we have a separate identification for the mode. And there are cavities. In the OPC-UA, cavity is one of the important part, so this one was categorized as a submodel, of course, referring to the OPC-UA. As for the motor drive, our first round of model was different. As for the motor drive, there can be many. OPC-UA companion specification is recommending that, so in the modeling, we follow the guideline of the OPC-UA. We worked on the first and the second round of the modeling. In the case of injection, engineering data modeling needs to be added. So let me give you a little bit more information. BOM aggregate was made. BOM is the bill of material, which can show the relationship among the entities. So, based on the physical structure, we created this BOM aggregate. And they are a part of the reference model. And I will show you how the engineering data was used. Mechanical breakdown is a part of the OPC-UA. And with mechanical breakdown, you can see the structure of the asset, the failure detection, and the failure diagnosis can be made. So, for the better management of the machine, and we have put the mechanical breakdown so that we can have better fault detection and for better maintenance. We have the CAD model, so the CAD model modeling was made. Some model collection and some of the properties. The CAD submodel was added, as you can see. In the case of the injection molding model, we have considered the enterprise application, and that is why we have added these components. And most of you probably understand what I am saying, but for your information, after the first round of the modeling, the job can be done on the AASX Package Explorer. When you are doing the modeling, on the property level, the ID needs to be linked. Aas reference model of the injection molding machine was created like this.
사출 성형에 대해서 우리가 AS 레퍼런스 모델을 1차적으로
Now, let me tell you how the injection molding machine model was applied to our test site. We have company called Ujin Prime, and let me tell you how that was working.
대상으로 한 설비는 우진 플라임의
Our target machine was TE110 electric injection molding machine.
이미지 요 모델을 대상으로
This one is all electric.
플라임으로부터 이 대상으로 하고 있는
From Ujin Prime, we received the data and we received all the device related data and we came up with the 3D model data and we also received the specification data. Based on the data we received, we worked on the modeling for field data coming from the OPCUA, and the second part is the technical data, the basic foundation. And I showed you the engineering part. And let me tell you how that has been implemented.
현장에서 OPCA 설계 데이터들을 저희가 받았고 이거는 일부입니다. 화면이 일부이고
We received this OPCUA tag data.
AS 상에 보시는 것처럼
Based on that, on the AAS, additional models were implemented.
그리고 테크니컬 데이터 파트 저희가 설비의 어떤 기본 정보들이나 사양
For
정보들을
the technical part, we received the specification information.
보시는 것처럼 전체 설비에 들어가야 되는 테크니컬 데이터들도 있을 수
All
있습니다.
the technical data for all the equipment.
케이스에 있고요. 그리고 보시는 것처럼 인젝션 파트.
And as you can see, there are some technical data specific to a unit, like the injection unit or the clamping unit.
추가적으로 기능을
They were additionally appended to the original model.
부분이 이제 엔지니어링 데이터 저희가 그
Today, I'm going to specifically tell you more about the engineering data, BOM, aggregate, CAD, and mechanical breakdown. That is all part of the reference model. When we were doing that, we had lots of homework. The reason we are doing that is to have a better use case and to develop a better business model. And we wanted to make people feel the benefit of AAS. I have shown you the use case of the engineering data, and they are critical data to a company. Actually, it is really difficult to get the data to put them into the AAS if the scenario is not proven to be really effective and working very well. It is really difficult to work on it. And when we apply the engineering data, we were wondering what can be the best use case and what can be the value we can find when we are using the engineering data. So we came up with the scenario first. This is the injection molding machine, and you will get the data based on the OPCUA. And this is the AAS model on the cloud web browser. The the operation data will be coming and the data will be collected. The dotted lines are not actually implemented in Ujin. However, they can be used for other machines to make the process more intelligent. That is why we put them into the scenario, of course, on the dotted line. We receive the operational data. Based on the operation data, we can tell whether the product is a pass or fail. And usually, the product coming out of the injection machine is cheap, so people are not working on the QA process. So usually QA process is skipped. They want to automate the QA process. And if we have the algorithm that can tell whether the product is a good fit or the fail, in that case, the scenario will not be working. But if the algorithm says the product failed, in that case, we can have the root cause analysis for the failure of the product. The root cause analysis can be made to find out which variable or which component of the device is causing the defect. And there are the three modules: mold, hopper, nodule. They are the three culprit for the defect. Usually. When there is a defect, there can be three causes. Then within our AAS, we can have a mechanical breakdown. Within the 3D map, we can see and you can be directly linked to the relevant onset. The sub-model has been implemented already, and for each of the asset, there is sub-models. And you can have the monitoring for the usual culprit or the defect. So within the AAS, you can see how the data is coming and what can be the cause of the defect. To make it happen, we have the mechanical breakdown for the hopper and the nozzle. We have the mechanical breakdown, and there is a link so that you can move around between the asset and submodel. When you go to the relevant submodel or the asset, you can see the relevant submodels. Within these submodels, there are some of the key properties that you should manage. There are mean max values, which will make the product as a good product or as a defect product. So there are parameters, the min-max values, they were put into the information. For the nozzle, we have the monitoring submodel, and there are some key parameters that we need to look at. On the mold, there are three parameters, and there are some min-max values available with the monitoring submodel. On the web browser, you can see the outcome of the implementation. The defect prediction algorithm will be running when you find out the root cause. Then mechanical breakdown information will be brought up. On the system level, you should be able to look further into it. However, please understand that that is a development in progress. And we will put that into the testbed after the full verification. This is the UI of the cloud web browser. You can see the sub-asset. And currently, we cannot have the breakdown of the 3D model. Currently, we are not fully ready. For each of these sub-assets, we cannot see the name right now. And once you click the mold, you can see the linked information. You can go to the asset and you can see the monitoring information. There are some predefined min max values. Let me play the video clip. I will play a video clip.
인젝션 몰딩 머신으로 들어가게 되죠. 이제 이 안에 이제 그 품질 예측 알고리즘에 의해서
And there is a quality prediction algorithm. And let's assume that you have the root cause analysis. You have the mechanical breakdown. And once you click, you can go to the relevant asset. And there are parameters that can be the culprit for the defect or the error. You can see the min-max configuration and you can see the actual value. So you can compare those two values. Once you click the actual value on the web browser, you can see the actual data, whether they are within the min-max threshold or not. And this is, of course, a sample data. This is pretty much similar to the production environment. And you can see there were some abnormalities that is going below the minimum value. And you can find out the business model. And whenever the value goes below the mean level, you can take an action. And whenever there is an abnormally, you can take an action. In the hopper, humidity, and temperature are really important. You can see the parameters about the humidity and temperature. You can see the real-time information. The same for the humidity. That's how we implemented on the Ujin Fly. We created a reference model that needs to be further modified by the experts. We are currently reviewing the comments from the experts. And if we need some amendment, we will apply the final amendment. For the AAS model, we came up with a generic model, but there are lots of machine types and various sizes of the machines. So we are going to customize the model for each of the type. An AAS model needs to be extended and expanded. As I told you about the engineering data, the quality, prediction, or the parameter algorithm, and there are various data sets that can be developed in this use case. The data and the relevant algorithm should be presented in AAS. That is something that currently I am studying. Carbon neutrality is also important topic, and we can put the carbon neutrality calculation within the machine and within AAS, and I'm going to further study on it. In the case of Ujin Prime, they collected the information, they monitored the information, but from the engineering perspective, they were able to come up with a new scenario and probably they can come up with a new business model. What matters next is how we can apply that into the testbed, and we are going to review it further, then we can finally implement that. That's it for my presentation. Thank you very much. Professor Lee, thank you. Thank you for the interesting presentation. For those of you who know about this, find it interesting, for many of you probably that can be really challenging. But this project, we have the reference model for the robot and injection molding machine. Data acquisition is something that we have covered already. The first round of project was completed. We created the manual and distributed the manual already, For those who studied that material can probably understand what Professor Lee was talking. And after the second round of the AAS project, we are going to build more documentation how we came up with the actual implementation of the injection molding machine and the robot. The guideline will be published. Once you can read that, you can understand it, and you will find it is not that difficult to implant on it. Once you understand the machine and once you understand the parameter, simply you can put the value within the tool. It is not that difficult for you to do it. So later, once the guidebook is published, you can refer to it. That's it for the presentation. We have two questions, and we are going to cover those two questions.
So after 2023, will we have the AAS-based smart factory in Korea continuously, just like Germany? So we started study about AAS from 2000, and we started to work with LNI for the data storage and etc. And then last year, we started to collaborate on engine manufacturing, and we are now testing on our test bed. And in the first year, data collection and storage on the cloud. Actually, this project started, and we will advance in a few years. And when can we apply this AAS on the cloud base is our task. And from this year, Korea's manufacturing companies will start to work on how to utilize the digital twin and make the cyber platform based on that. That means we need to realize this AAS on the cloud platform. So this year, we will continuously work on the digital twin based on the cloud. Then, in the near future, we will start with the AAS, and then the business will be transformed to start based on the AAS. Otherwise, it will be difficult to lead the global market in the future. So that is why we are collaborating with startups and SMEs now. But we hope to work with the global level big companies of Korea like Samsung, so that we can make this a private-led project while getting support from the government.
The second question was in English.
I think this is a question to Mr. Make from the IDTA. I believe that the question was about how to apply this mathematical formula when we make the AAS-based digital twin, because we need whether we can actually apply this on the step-by-step algorithm. I was wondering whether our German colleague, maybe Mr. Mike or Dr. Anja or Dr. Jens, can answer this question.
What's the great advantage of AAS is that it's so flexible. We are providing a software architecture, and you can implement basically nearly everything within those submodels. So you can have behavioral models. If you look on the list of information on the submodels on our website, you see the totally different contents you can place within these submodels. So I guess we are really flexible and we can integrate most of the things. The question is in the end of if we are able to standardize those things. So it's a common submodel for everybody. But of course, you can do your individual proprietary submodels if you want to integrate, for example, a behavior model, mathematical models, or whatever. So I guess the answer is yes, you can integrate those things. Probably we won't have standardized submodels for every and each specific and really special thing.
Yeah, I would like to extend that, Mike. Thank you very much to bring that standardization focus on the table. I know the description of digital twin from my previous role, and I know there are a lot of mathematics inside of a digital twin, so to say, and the intention of the AAS to be or to provide a metadata model who is going to describe the features of the things, the assets we want to insert in the AAS. Might it be a machine? Might it be a software? And in that case, the features or the properties of these formulas in the mathematics could be a good anchor point to be described in a submodel, but the calculation themselves, that is very specific, and it must be evaluated if there is a separate submodel required for that. But the general description, the features or the pieces and pieces you need to calculate on digital twins, that could be a very good starting point to provide a submodel for a digital twin as a software asset.
There is another question directed to Professor Lee. Professor Lee, can you make a comment? Can you read the question about the quality prediction algorithm? As I told you in my presentation, in the case of the Ujin, actually developing the quality prediction algorithm is out of the scope. But the reason I'm showing you is because BOM and CAD are really important data model. Once the company cannot see any value about the AAS implementation, they are not going to work on it. And that is why I borrowed some of other scenarios. For example, intelligent factory and the analysis about the machine. Based on previous intelligence business cases, I borrowed a use case. As far as I know, currently, the data analytical model and the mathematical model can be presented, but there is no specific guideline. So internally, the basic formula and the basic mathematics can be presented. And there can be various ways of the implementation, especially the data analytical model cannot be simply implemented. Probably de facto models are already existing, and there are some people who are working on that research field. So the analytical model should be represented in a neutral way, and probably they can be brought into AAS or integrated with AAS, or you can use them along with AAS. The scenario I told you about the quality prediction is a simple example scenario, probably that can be implemented even though that's out of scope right now. The second question is, yes, for the injection, we created a model, but for the PCB and the pressing machine, if there are needs and if there are supports from the government, yes, we can create a model. Then AAS can be utilized in various manufacturing processes and various factories in Korea.
So AAS means digital twin. So when we have asset, then when we digitalize it, it's going to be AAS. So when we make the digital twin AAS, then we can have that estimated scenario. And in addition to that, we can have all those possible scenarios in digital form. So we can know what's happening inside the machine. So we can know about all those solutions for all different verification. So there's another question to you.
And I heard there's a new question. And there are many relevant stakeholders, and probably that's why they are asking questions about the injection molding. Of course, the quality level and those kind of quality criteria shall be different company by company. When we are creating the reference model based on the carbon neutrality or something else, AAS has various models already. And when we are presenting the model, actually we cannot have a customized model that can solve everything. We first put the generic models. When we are combining the generic models, we need a combination, of course, but we are using the data of yours, and we need some tuning and data analytics in the middle. And in that process, for each of the company, probably data set A can be critical to company A, and data B can be critical to company B. And we want to have a case-by-case analysis on that. We are supposed to finish the forum by 7:30. We have only 8 minutes left. I told you that I'm going to finish this forum by 7:30, and I'm happy that I can conclude this forum in time. It is 7:30. It was beyond the dinner time. Many people feel hungry at this hour in Korea. So let me conclude this forum. And once again, from the German side, the presentation was really important and really meaningful. And you have discussed some of the key questions that many of the Korean stakeholders should have. And also, we have updated what is going on within the second pilot project of AAS. I would say this forum was really useful. I am not sure when we are going to have the third forum, and I hope we can have more in-depth discussion, and I hope we can have more face-to-face participants. Once again, thank you very much for your contribution, and let me announce the conclusion of this forum. Thank you.